of Mr. Andrej Kiska, President of Slovak Republic. So it's commitment to do everything as best as we could, and we are happy that we get this privilege. So I would like to thank Faculty of Informatics and Information Technology that we can be here, and I would say a few organizational stuff. So let's stay connected, and there is wireless PyCon SK, and you can see the password on the screen. We are using Slido for the conference, where you can ask questions, and the questions get likes, and the questions with most likes are read. So stage manager will read them, and the speaker can answer. Official hashtag is PyCon SK, so please do tweet, post on Facebook, whatever, and use this hashtag so we know what's going on. We have a code of conduct. So as when you purchase the ticket, you agreed to behave nicely to each other. So if you didn't read it, please read it. But I think it comes naturally. Just be nice. And we have sponsors without whom this conference wouldn't be able. So I would like to invite Mr. Victorin to say a few words about Red Hat.
Right, hello everybody, I'm Peter Victorin, and about Red Hat, I guess some of you know that Red Hat makes this Linux distribution called Red Hat Enterprise Linux, but that is not the only thing Red Hat does. We're involved in a lot of different projects. Some of them are run by Red Hat engineers like FreeIPA. Some of them we just contribute to a bit, like CPython itself. The thing that all these projects have in common is that they're all open source. So everything we ship to customers is open source. There are some exceptions, generally if we bought some company and didn't yet manage to open source all their code, but that's about it. Otherwise, we're not even afraid of the GPL. And some really smart people figure out a way how to make money from all of this, so we can even sponsor great conferences like this one. And yeah, so if you'd like to learn more about what we do or the projects that we're involved in, there's a booth, either the Red Hat one, or there's a more community-oriented Fedora booth, so you're welcome there. Thanks.
Our other gold sponsor is Asset, and I would like to ask Mr. Hudek to say a few words about Asset.
Yeah, hello everyone. Indeed, we have a pretty nice gathering here today. But first off, I would like to welcome you all on behalf of ESET. And you may wonder what is ESET doing here. There are no viruses around. But not all of us are reverse engineering nerds, a lot of us are quite common software engineers who like high-level programming languages like Python. And of course, we do not use it for production code, but we use it a lot for internal tools. And actually, one of our most successful bot in our bot wars game that was used for our hiring campaign was written in Python. So you didn't come to see me, so I'm handing over to the first speaker. And enjoy the conference. Thank you.
So schedule for today you can check on the website. We have live streams for boardrooms, a large auditorium and a smaller auditorium. You can check it on the PyCon SK website or on a YouTube channel. There is hashtag PyCon SK. Or you can import the ICS calendar to your favorite app. If there will be any changes, it will update automatically for you. Goodies. We have some goodies from the sponsors, so please check out the PyCon SK Twitter account for competitions today. You can win cool prizes. And lastly, I would like to thank you all that you come here, because this is a community event for community, and since you are here, you are the community. But more than that, we have an international community here. You can show that the organizers from PyCon Czech was here yesterday, and they are here today. We have also organizers from PyCon Poland here. Filip here. He is going to be the stage manager for today. Thank you for helping us, Filip. And we also have PyCon UK organizers here. So our keynote speaker Nick, this is and other guy. This is his job. So let me pass the word to the Filip, so he can introduce you the first speaker, and enjoy the conference.
So, hello, I'm Filip, like Richard said, and I would like to introduce the first speaker. It will be Nicholas Tollervey. I would say he's a man of Renaissance, because he's a trained musician, philosophy graduate, teacher, writer, and software developer. And he's heavily involved in the education topic, and his talk, Teach, Learn program, will be about education. So, let's welcome on stage Nicholas.
So let's see if the microphone's on. Can you hear me at the back? Yes, people are nodding. Fantastic, thank you. I'm going to stay seated. You'll see why, because there's most of this talk will actually be a practical demonstration. I'll need to be sitting at the keyboard, so it'll either go really, really well or be a complete disaster. But in either way, it's going to be really entertaining for you lot, I hope. So this is a great first conference, and thank you for inviting me. And congratulations to the team for such a sort of professional show that you've put on here, and long may it last. I hope that there are many more PyCon conferences here. So my name is Nicholas Tollervey, and I'm a freelance Python developer from the UK. My background, he said, music, so here's the obligatory picture of me playing my instrument. I'm a tuba player. I used to earn my living playing in orchestras and things. But I met my wife and wanted to get married, and musicians don't earn a lot of money, so what do musicians do when they don't earn money? They become teachers. So this is me on my first day as a school teacher with my form. I used to be a school teacher, and I'm still very passionate about education, still as a software developer. And so I've been involved a lot in the programming and education work in the UK that's been happening, and O'Reilly wanted me to write a book about this, so there's my obligatory plug of my book there. And interestingly, internationally, people seem to think that we're doing interesting things in the UK as well, so I wanted to sort of share a little bit about that. And perhaps the most important thing, because we're at a PyCon, is that the UK's Python community are, I guess, at the heart of a lot of the changes that are happening in the UK programming and education work that's going on. So what I'm going to do is I'm going to discuss how we as programmers can engage in this world of education. And I'm going to start with an assumption. I'll do some karaoke here for you. A good developer is always learning and re-evaluating in order to improve. And this is a bit obvious, really, because in such a fast-moving industry, things are changing all the time. I was talking to Cory this morning in the car, and we were talking about how this library changes because, you know, security and things like that, and you have to keep relearning and things. So we have to learn. It's part of our job. And I'd like to ask, is there anyone here who's so talented that they don't need to learn anything from anyone? You'd need to be rather an arrogant individual if you thought that yourself. And if you are thinking that, then I suggest you're fooling yourself, really. And teaching and learning are, I guess, at the heart of what we do. We'll see that in a minute. And I quite like the quote from Socrates, where he says, wisest are they that know they know nothing. Because, you know, you have to be quite humble when you're learning as well. So, talking of humbleness, here's a quote from me. This was done in a discussion on Facebook with some teaching colleagues. I'll read it out again for the sake of people who can't see the slides. Asking what sort of education and learning our community supports is how we decide what sort of community we become. For it is through education and learning that we engage with our future colleagues, friends, and supporters. And this is essential for a community like Python, which is a free and open community. But education isn't just about personal development. Its effects are far wider and sort of long-term. And you might be asking, well, what has this got to do with me? So, this picture is of Ravi, who's a colleague of mine, explaining something in the London Python Code Dojo. And if you already know how to write code, you might think, well, education, it's not really of any interest to me. But if you're good, you'll know that development involves learning. And when you're in a position of responsibility, like Ravi obviously is in this non-staged photograph, teaching others how to write code and how your software works is an important aspect of what we do. This is why we do code reviews. This is why we pair program. And when you pair program, you have to interact, and that involves teaching and explaining and things like that. This is an important skill that we need to have as developers. So to be a programmer is to be a teacher and a learner. But this doesn't just apply in a professional context to us as jobbing Pythonistas, as it were. This is something that we can do to engage our future community. In 10 years' time, when I'm a lot older and I come along to PyCon Slovakia, the kids that are 11 or 12 years old now will be the ones on this stage now. And what can we do to help them become members of our community? So it's important to engage with children, I believe. It might be a bit frightening when you stand up and there's 30 11-year-olds looking at you. It's quite disconcerting, I can tell you. But to describe programming to children indicates that you know your craft at a deep level. Why is this? Well, you appreciate what to leave in and how much to leave out. And you make, and this demonstrates sort of the clear mental models that you might have, so you know how to analogize and summarize the knowledge that you have. And being able to explain yourself in simple and easy to understand library is also a demonstration of your own clarity of thought. I don't know about you guys, but sometimes when I sit down with colleagues and there's a really gnarly problem and you end up sort of going around the block because you just can't explain it in a simple way. But actually trying to work out how you might explain it helps you shed light on what that particular problem is. And also, just working in this way with young members of our community is a sign of moral and professional value. It's an unambiguously good thing to do, really. So, in Slovakia, I'm not quite sure what your computing curriculum is like, but in the UK, until about, I don't know, 3 or 4 years ago, it was essentially a little bit like this. It was a glorified Microsoft Office program of study, really. And there was and there was no actual programming on the curriculum, and often it was delivered by teachers who had no computing expertise because they were business studies teachers. Okay, and also teachers, I don't know what it's like in Slovakia, but they get a bit of a bad rep in the UK. Here's George Bernard Shaw: those who can do, those who can't teach. You can't really get much worse of indication of what it's like to be a teacher than George Bernard Shaw. But teachers are the single most important aspect of delivering the sort of change that we want to encourage children to program. So what do teachers make? Well, they kind of make a difference. And teaching is the one profession that creates all the other professions. And it's a calling, because you're certainly not doing it for the kudos or the money. Anyway, you're not in the UK, you're not. And also, as a teacher, teaching is the hardest job I've ever done. So, you know, when the servers are melting and the clients are on the phone and everything like that, as a programmer, that's nothing compared to some of the situations I had to face as a teacher. So at PyCon UK, we welcome teachers to our community. Here's a whole bunch of teachers that turned up in 2012. And we remove as many bureaucratic barriers as we can to them coming. So we actually more or less make it free for them to attend. And we connect them with developers as well. But education isn't just about teachers. We also run a children's track as well at PyCon UK. And like I said, kids are our future colleagues, friends, leaders, and collaborators, and we should welcome and help them and cherish them and all that sort of stuff, and embrace their enthusiasm, because when you walk into a room full of 100 children, it's sort of coming out the walls, the enthusiasm, as it were. So we make it ridiculously cheap for kids to turn up, 100 or so. It's high energy, lots of fun, and we get outcomes like what you could see on the screen. So there are going to be 3 children here. There's Amelia, and then the little boy is William, who's my son. He was about 5 at the time. And the chap whose mouth you can just see appearing out of the top corner of the photograph is my older son, Sam. And they're working on a Python problem. They're trying to program Minecraft on a Raspberry Pi using a Python API. And Amelia's looking a bit worried about this, and obviously something's gone a little bit wrong here. Sam's moved on to the sort of scene, and he's having a look as well. It's not worked quite how they were expecting this code to work. But Big Brother, he's spotted a problem here, and he's helping them out, and they've pressed F5 again, and no, there's no syntax error anymore. Is it going to run? Is it going to run? Yes, it's going to run. We've all felt that sort of a feeling as software developers, okay? So, kids at PyCons are good. So the future, inventing the future. With our children. Alan Kay says the best way to predict the future is to invent it. And in the UK, lots of groups are starting to realise this. So one thing for certain is that computing will be a huge part of our future. So it's important that people are confident to connect with this medium, and they're good digital creators. So this was my first computer. This is the slide that you particularly wanted to see of the BBC Micro. This was given to all schools in the 1980s. My dad was a head teacher. He came home one evening with this computer, and within about 5 minutes, my brother and I had managed to take this off him and plug it in and started playing. And I remember my first program. It was 10 CLS. This was a basic machine, so that was a clear screen. 20 print. Quotes, Andrew is an idiot. Andrew was my brother. 30, what was line 30? Go to 20. So Andrew is an idiot. It's all at the screen. Okay, fist fight. My brother as well actually is a programmer as well. Okay, but Dave Allen, the producer for the BBC Micro, he said the aim was to democratize computing. We didn't want people to be controlled by computing, but to control it. And I think that's a very laudable aim that we're aiming for. So fast forward to today, and the BBC have created a moonshot project called the Microbit. And in 2 weeks' time, I can't believe it's that close, in 2 weeks' time, 1 million small programmable devices are going to be given to the UK's 11 and 12-year-olds. Every single one of these kids is going to get one of these small programmable devices. It's being created by 20 or more partners. The Python Software Foundation, of which I'm representing in this, is one of them, and it runs Python. So this is where the fun begins. Right, so. This is a microbit. Let me just explain what's on the board. You have 2 buttons on the front, here. You have a 5x5 LED matrix. It's even got a hairdo. And across the bottom, where the teeth should be, are I/O pins. And the way they've been created, as you can see, if you know what a makey is, you'll understand. You can attach crocodile clips, or you can plug it into an edge connector like this, and then break out into a breadboard. Okay. On the back, all the parts, all the components are labelled. So there's a compass and an accelerometer and things like that. You can stick batteries in here, a reset button, obviously USB goes in here. So let's get rid of my ugly mug. Actually, let's not. So we have an editor here. Okay. I guess the first thing I should do is connect to the device, which is what I've just done. So this is a REPL, a Python 3 REPL, running on this device. Damien George, the creator of MicroPython, which is the version of Python that we use, has created a full re-implementation of Python 3 for microcontrollers. So everything Python 3 can do, you can do on here. It comes without the standard library, but we've created a module called Microbit that allows you to interact with the hardware. So, in theory, I can do things like that, and it's evaluated and it returns. But I can also do, it's really disconcerting typing here when actually the thing's up there. So I'm just going to change my screen so I'm mirroring displays. Mirror. Is that going to work? I'm not sure. Mirror. No, that's not going to work. Oh well. Okay, I'm going to get a stiff neck then. So, I can type display dot scroll. Hello world. And then if I'm quick, hello world. There we go. So, not only can I use the REPL to evaluate commands and things, I can create code up here and, well, let's see. I can just flash the device. So you can see it flashing here, showing you that the thing's being flashed. And it's a very sad microbit. But if, let's see if I can do this right. If I tickle it, oh, come on. Yeah, there we go. It'll smile for me, okay? So these are fun little programs written in Python that kids are going to enjoy. What else does it do? So we have Magic 8, very simple piece of software. We've got a list of answers here, and that's essentially the program that we have. You might be wondering, I can't see that at the back. We know this because teachers tell this all the time. So we've created the editor so that you can make sure that the people at the back can see the code that's there as well. And also, sometimes people find it easy with projectors to have a dark a dark theme. So if I flash this onto the device, we have a Magic 8 ball. So the way a Magic 8 ball works, here's the Magic 8 ball, and you ask it a question, and you shake it, and then it gives you an answer. So my question is going to be, is this the most awesome PyCon so far in 2016? You may rely on it. Awesome! It is the most... Cool. So, I think, like I said, in 2 weeks' time, 1 million children are going to go and get one of these devices. Let me get rid of cheese. But let me show you what else they can do. They can, if I focus on here. So this is the BBC's website, microbit.co.uk. If you go there, you'll find out all sorts of details. There is a web-based editor, Python editor, built into this as well. So you download the hex file and you copy it over to the device. And so kids don't have to use the editor if they don't want to. When we were... We only had essentially one device for most of the development of this, but the BBC gave us about 5 devices, and we tried to work out what could we do to engage the Python community and create some resources for the kids to use. So we sent them on a world tour, and they went everywhere. So a couple to the US, one to the South Pole, New Zealand, and so on and so forth. And if we have a look, people would supply blog posts with various different things that they've been up to. So Radomir from Poland, who's currently in Switzerland, did some robots. I'd like to attempt to play in a conference on conference Wi-Fi a YouTube video for you. Let's see how that goes. But this is Radomir's Bob robot. This is brilliant, I think. I think it's rather cute in a all humans must die sort of a robotic way. But the point is that Radomir has provided all the source code and the plans and the things that a teacher at school can use to then take this class of 11 and 12-year-olds. They can all bring their device, plug the device into the robot, or make their own robot if they're in a technology lesson. And you know, this is inspiring kids to program. So I'm running out of time, I think. 5 minutes, thank you. So the documentation is on Read the Docs, okay? That includes tutorials and everything. There are also lesson plans as well. So your homework, I used to be a teacher, so you thought you could get away with this, but no. If you're asking, well, how could I get involved in this? What could I do? Well, obviously, everything to do with the microbit is going to be open sourced. So all the hardware schematics and information for how to recreate one of these devices is going to be released under an open license. So anybody, without having to ask permission, will be able to just manufacture these, obviously pending the appropriate certifications and things. But you'll be able to see how it works. All the source code is definitely open source. So you can get involved and you can help and you can teach. Wouldn't it be lovely if there was an education track at next year's PyCon Slovakia? And what's stopping Slovakia from having a microbit as well? Everything's there for you to take this and make it your own. So that's when your homework's due. I think that's it then. I have questions.
Okay, let's move to the questions. The most voted one is, are there any plans to make the device available commercially?
So, I've come prepared. So these are frequently questioned answers. So, when and where will the device be? It'll be you'll be able to order it just like you do with the Raspberry Pi via mail order over the summer. The kids are going to get it first, and then I think June, July time, you'll be able to order them from places like Farnell online.
Okay, so the next question, what other environments and tools do you use when teaching programming in Python?
So, the Raspberry Pi, hands up if you know or have heard of a Raspberry Pi. That's pretty much everybody. Okay, so Raspberry Pi is another UK-based teaching success story. So Raspberry Pi is very popular in schools, and teachers in the UK anyway seem to love Python. So there's lots of, what I'm saying is there's lots of grassroots teachers creating resources and things to teach Python.
Okay, next one. Are there any extensions for microbit? We already seen one, I think.
Yes, so you will be able to get hardware like this, so a breakout sort of board. I've seen, no, I'm not going to tell you about that because that might be secret. There are plans afoot, is all I can say. So there will be something equivalent of being able to stack devices on the bottom. Somebody's designing something so you can just screw more bits and bobs on, and each, a bit like a shield on an Arduino, you just sort of add more capabilities.
Okay, so the last one, the most interesting question. Do you want to play for us?
In a musical sense?
Probably.
Unfortunately, as you saw, I'm a tuba player, and getting a tuba on an aeroplane is, well, it's not a nice thing to do, so alas, no. If there was a piano, I'd play for you, but there isn't.
Okay, so that was the last question. So thank you for your talk.
You're welcome. If you want to find out more, just find me in the halls and things, and happy to chat. Thank you.
Thank you. So now there's a 10 minutes break at least, or even more, 12 minutes. talk. Our next speaker will be Bjarni Runar Einarsson, who came from Iceland. And his talk will be, can free software be a full-time job? So let's give him a warm welcome.
Thank you. Everyone can hear me in the back? It's good? Okay. So, hello. I'm Bjarni. I'm a free software hacker from Iceland. I met one of your organizers, Richard, at PyCon UK, and we were chatting. He asked me to come and tell some stories about what I've been doing in the last few years. Because since about 2010, I've been trying to make free software my full-time job, and I haven't done this by getting employed by a big company, so I've been trying to figure out how to do it myself. Some success, but I have some stories to tell. I'm not an expert. I don't have a book to sell or anything, but I have some stories. You can learn from my mistakes, maybe. For the purpose of this talk, I'm going to be talking about free software. You can imagine that I said open source every time I use the term free software. They're mostly the same. I use the term free software because I care about the freedom and the politics and the ideals, all the stuff that the open source term was invented to sort of de-emphasize. But why would you care? Why would you want to go and make free software the focus of your career? And in my case, it really goes back to what Nick was talking about earlier. I discovered free software very early in my career, and my career is to a great degree thanks to free software. I got my first programming job when I was 16, and I was writing accounting programs in C. Now, not a good idea. Don't hire 16-year-olds to write your accounting programs in C. Just don't need to tell you that. Hire them to do it in Python instead. But I learned a lot, and I discovered that I really wanted to be a system administrator because that was that cool guy who ran all the computers, and he had root, and he was boss. So I wanted to be him. I went and I downloaded Slackware Linux and put it on a stack of floppies, took over the PC at home, and I taught myself to be a sysadmin. And that was it. Since then, I've been doing system administration and software development as a job. And I want others to be able to do the same thing. And I want to be kind of like those cool guys that gave me these tools at an impressionable young age. I'm still trying to be as cool as they are. And also, computing is kind of important for society. We don't want the code and the infrastructure that runs how we communicate and how we work to be proprietary. So free software and open source is a very important thing. So can it be a full-time job? These days, the answer is yes, of course. Most of us probably use some free software at work. Some of us get paid to write free software. If you're working for a large business, then that's become relatively common. I think most open source and free software projects are written by people at work. It's not hobbyists doing all of this. But the tricky bit, and the answer becomes no, when you have a project and you say, hey, I like this project, someone should pay me. And that brings me to this beautiful image, putting the cart before the horse. If you already have the project and you already have this idea of what you want to do, there's a lot of things that you don't know. You don't know whether anyone is willing to pay for that. You don't know who they are. If someone's willing to pay for it, who are they? And you don't know how much they're going to pay. And because you're a software developer, you probably don't really care. You're not a marketing guy, you're not a business guy, you're a hacker. So the other question you don't know is you don't know if you're solving the right problem. So you might be solving your problem. You don't know if anyone else likes the solution or has the same problem. So I've tried this 3 times so far in my career, and we're here to laugh at my mistakes or learn from them or something. These are the strategies that I've tried. Strategy number 1 was to apply for a job and have someone create the job that I wanted to do. Strategy number 2 is selling stuff, selling services, selling licenses, consulting, contracting, sell people stuff they'll pay for. Strategy 3, get a grant. That's when you find someone that has too much money and you ask them to give it to you for no good reason. strategy 4 is the same, except you ask the entire internet to give you money. And that works for a different class of projects. There are some projects that you can crowdfund. There are others that you can get grants for. They don't necessarily overlap a lot. And then there's the option 5, is to retire. And I mean that's sort of an exaggerated example, but if you are in a position where you're well paid at your job, and you can get away with working 3 days a week, that means you can spend 2 days doing whatever you like. So this is one way that you can fund developing software that you care about, but you don't necessarily know how to find a market for, is you can just have a day job a few days a week or a few months a year, take some time off, do the things you care about. So the first example, and I apologize, it's Perl code, but I did say I was going to talk about some mistakes I made. So this is my haircut when I wrote this code. So this was 1998. I started working on this. Excuse me. It was a security filter for email. So it was a tool that would take your email and it would rewrite it to avoid certain exploits that mail clients were vulnerable to strip out executable attachments so that you wouldn't get a virus. And I decided after a while, I've been doing this for a few years for fun, I thought, hey, this could be a job. And I was lucky enough that in Reykjavik, my hometown, there was an antivirus company. Does anyone here remember FPROT antivirus? Yes, some people. They're an Icelandic company, or were, and they were based 3 minutes from my house, walking. So I walked to their offices. At the time, I was not just rocking that haircut, I also had a top hat and leather pants. I was doing the goth thing. And I said, hey, why don't you hire me to create an email security service? So that's strategy 2, except I was asking them to take the risk. They would they would take care of selling it, they had the reputation, they had the missing pieces needed to take my solution and turn it into a product. And it worked. We built an email security service where we would scan email for businesses. At the high point, we had 2 different national ISPs sending all of their email through our code. The low point is when we lost an entire nation's email for 24 hours. That was not a good day. But this was not actually a success story from the point of view of making free software my full-time job. Because although I did find an employer that needed my skills and was willing to let me work on the things I wanted to do, they had the things I needed. We found people to pay for the product. I didn't end up writing a lot of free software. I ended up mostly writing proprietary code that was kept inside the business and has not been released to this day. And the open source code that I arrived with, the free software project that I was passionate about, it languished because I was too busy doing my job. And so that's the risk of this strategy, is that if someone's paying you a salary, you have a job to do and you have to do that. But it was a good attempt. The other lesson that I learned there was that the code that I had written was not solving the right problem. It was not solving a problem that in a way that people were happy with. So this is something that you only get when you have a bunch of users. When users are telling you their experience of using your software, that's when you really know whether you created something good or not. And in this case, Anime was actually not very good. It just confused the users. They were like, why has my email been rewritten? That's frustrating. So, second story. This, fast forward to 2010. This is called PageKite. This is what it looks like on the command line. PageKite is a proxy solution that makes it easy for you to run a website on your laptop or on a home computer without reconfiguring your router. So there's a relay server or proxy that runs somewhere in the cloud. You run a client that connects to it, and traffic flows back and forth. And I created this because I was concerned about personal privacy of data, and I thought that social networking was important. I was afraid of Facebook, and I still am. How many people here know about Diaspora? Okay, so this was about the same time. Diaspora was a brilliant idea. It was, you were going to make this thing that worked just like Facebook, but you could run it yourself. The trouble is that they never really considered how hard it is to run something by yourself at home. And PageKite was supposed to fill the gap. It was supposed to be the bridge from the software running on your Raspberry Pi to the internet and not require that you learn to be a sysadmin and reconfigure your router. I founded a company around this idea. The idea was to sell services and support, in particular to provide relays on the internet that people would pay for access to. And I got a grant. So this was strategies 2 and 3 from my list. The high point so far, I had 3 or 4 employees, depending on how you count. Unfortunately, the low point is I had them all writing code that I ended up never using because I'm a terrible manager. Report card for this, again, from the point of view of making free software my job. We did a good job releasing everything. Almost all of the code that I've written in this venture is open and on GitHub. We did manage to get a grant, and this was not some idealistic grant. It wasn't an NGO, it was a government grant. So in Iceland, you can get a grant for developing a new business. And I'm pretty sure Icelanders didn't invent that concept, so there may be such things that you can apply for here. And we're going to talk a little bit more about grants towards the end. We did find a market. It turns out that the Internet of Things, where people are building small gadgets that you plug in your home, it's really useful to have a web server in those, and it's really useful for that web server to be reachable without the consumer having to know anything about their network. So I'm now selling technology to businesses that are shipping devices to people's homes. And a lot of the time they're shipping Python code. So that's growing. Failures, I wasted a lot of money. The market that I thought I was going for and the problem that I wanted to solve, the social networking thing, that never happened. That still hasn't happened. Maybe it will. Don't know. But it's still a going concern. It's maybe 20% of my time is still working on PageKite, and I'm still developing new features. Third project, again different. This is a project called Mailpile, which has been my most popular attempt. This I started with 2 friends, or 3 of us. We met in the hot tub in Reykjavik. We crowdfunded on Indiegogo. We went to Indiegogo and we pitched to the internet, hey, you should be able to run your own Gmail at home, and you should be able to easily encrypt your email. And we timed this completely by accident, so we went live with the crowdfunding campaign the same summer as Edward Snowden told everyone what the NSA had been up to. So people cared a lot about privacy. It was also the same summer that LavaBit went out of business because they wouldn't give their encryption keys to the US government. So there was a lot of press about privacy and security, and that translated into a lot of people throwing money at Mailpile. So we raised enough money to pay for 2 developers to work full-time for 1.5 years. We also applied for some grants, and here, crickets. We've gotten no grants, even if it's a project that a lot of people like. And strategy 5 is the retire option, because we ran out of money without shipping a 1.0, which is, again, managing software projects is hard. I'm still working on this, but right now I'm paying for it out of my own pocket. High point was, of course, when Cory Doctorow said we were cool. This is unfinished, so I'm not giving myself a grade. Again, we managed to release all of our code as free software, so there's no proprietary side to Mailpile. The timing was good, we raised a lot of money, that was all really cool, we got a lot of attention, and we actually, as a result, have a community. And that's one of the best things about crowdfunding, is that it gets you attention. People know about your project, they want to take part, they invest money. If they're willing to invest money, maybe they're willing to send a patch or 2 or some bug reports. Failures, no grants. We don't know how to get grants for this software, apparently. Project management, at first we didn't think we needed project management. We just wrote some code. When we realized that we needed some project management, we were out of time. So we actually ran out of money before we shipped a 1.0 that our backers could use. And if I have backers in the audience here, I apologize. Still working on it. So what lessons have been learned from this? Just a few sort of concrete things that you can take with you. Grants are hard. When I've succeeded in getting grants, it's because, well, the main success was when I applied for a business development grant to develop a business. And that sounds redundant and it sounds like a tautology, but it's actually a key point, that I was applying for a grant to do the thing that the funder wanted me to do. Whereas with MailPile, when we applied to NGOs and we asked them for money, we went to them and we said, hey, look, MailPile is awesome. This is this beautiful concept. We're really great. You should give us some of your money. And that's not what they wanted. When people have foundations and are offering money, they do so for a reason. They have a goal, and they want you to solve their problem. So you can't just go to a funder and say, I have a cool project. You have to go to a funder and say, I am going to solve the problem you have. So it is in many ways much more, it's like getting a job or selling a product in that respect. So trying to learn this lesson, maybe I'll try again sometime. Crowdfunding is the new kid on the block. It's very exciting. The pros to crowdfunding your work is that you have complete freedom. If you present an idea that people like, you can get almost anything funded. Of course, this means you have to be good at some sort of marketing. You have to have a group of people that you can reach out to and communicate, get them motivated and get them excited. And that's easier said than done. I got lucky that I had one of the team members on MailPile was very good at videos and visual communication, so that helped. But mostly we got lucky. Mostly Edward Snowden did our marketing for us. Crowdfunding allows you to do things for the general public. It's very easy to find a job writing a software development tool or a library that is used at that job or is used by other businesses. It's hard to get funding to build the next Firefox. Or actually, Firefox has a pretty clear business model, but maybe something like LibreOffice, which doesn't have ads and doesn't have a clear business model, a project of that nature is much more hard to get corporations to pay for. So if you can convince the general public that you're writing software that they want, crowdfunding may be an interesting solution to that. The cons, of course, the downside is that when you crowdfund, you get a fixed amount of money, and then that's gone. So if you want your project to be sustainable financially, you have to do all of that work within that time frame that you're given. Also, most crowdfunding campaigns ship rewards. They ship t-shirts or pens or USB sticks or physical devices in many cases. And I've seen a lot of crowdfunding campaigns sort of fail to account for the costs of that. Or conversely, they fail to account for the costs of their own salaries. Now, software developers are well paid until they start working for themselves, because usually they don't know how to value their work. And I see this again and again with crowdfunding. There was a very nice, it was a good project, some French guys that wanted to do an email in a box hardware solution. And I think they were asking for like 70,000 euro or something. And that was supposed to be for the hardware and the development for who knows how many months, for 2 people. I mean, these guys were going to work for less than minimum wage under a lot of stress on a complex problem. And that's not realistic. We can't build our infrastructure that way. And when you have a successful crowdfunding campaign, you have thousands of people that have backed you, there's a little bit of pressure. It's really embarrassing to be up on stage and say, well, I kind of failed. I haven't shipped what I promised I would ship. And I felt really bad about that for a while. But when you have a large group of people that have backed you, in my experience, communicating honestly, publishing work as it's, not when it's beautiful, just publish it. Release the code immediately. Document things, write blog posts, go to events and talk to people so they know that you're working on it. And they will forgive you if you fail for a legitimate reason. And failure is very likely because project management is hard. So end this on a positive note, just do it. If you have an idea that you would like to turn into a business, give it a try. But if you have an idea and you don't know how to turn it into a business, write it anyway. Not all projects have to be jobs. It's really hard to predict what will work and what won't. And if you're scratching your own itch, probably someone else has the same itch. Sort of a spin on my strategy number 5 of retiring is to take a holiday. Take a break, go somewhere, write some code, learn a new skill, And that can lead to an entire new job, an entire new career, even if it's not exactly the project that you started on. So go out and write some code, and good luck. So I'm hoping that that triggered some questions. I rushed through that a little bit so we'd have time to talk.
Okay, so let's start with the first question from Daniele. Which open source software license do you prefer?
That's a good question. From an idealistic point of view, I prefer the GPL family of licenses, but I'm strategic about it. So if you are trying to create a new standard, like say an image format or a network protocol, using a liberal license is the right choice because you want people to adopt your standard and use your technology almost no matter what context. On the other hand, if you are building some sort of network service where you want to be able to run a business on the side, something like the GPL, a strict copyleft license, actually gives you more business options because then you have the option of dual licensing and offering people a proprietary license if they are allergic to the GPL. If you go with a liberal license from the very start, you won't have that option. The other thing that GPL licenses do is they create sort of a common playing field. Everyone is playing by the same rules. No one gets a big head start by releasing some things and keeping some things private. So it really depends on the project. And like in the case of Mailpile, we didn't know because on the one hand, we wanted lots of people to use it. We knew that the GPL would be controversial in many circles. So we considered, to begin with, we licensed it under the Apache license, and we also licensed it under the AGPL. So we had both licenses on the same code base. And then we asked our community to vote. And we had people vote on which license they preferred. It turned out that they didn't really care. Like 80 or 90% of the people just didn't bother to vote. The few that did, I think we had 51% for the GPL and 49 point something for the Apache license. So I ended up making the call. You know, we talked about it in the core team, and I ended up saying this project should be an AGPL licensed project because this project is about freedom specifically. It's specifically about users being independent and autonomous and owning their data. So using a license that is a little bit hostile to people that want to build proprietary software was the right choice in that case. But it's a tough call.
Okay, so our next one, quite interesting question. If given a second chance, what would you have done differently to have been able to ship Mailpile 1.0 in time?
Project management of some sort. We did a very typical thing where we sort of flailed about and wrote interesting code because a year seemed like a really long time. We wanted to ship something within a year, and you know, next year is really far away. But after you've done that for 6 months and you suddenly realize, wait a minute, how do people install this thing? It can take another 6 months just to figure out what your installation and setup story is. And it turned out that that needed more than 6 months. We weren't able to get it done in time. So I think that if I were starting over, I would probably prioritize things very differently. I would prioritize being able to get people up to speed so that people could install the software right away, even if it was in a poor state, and then start adding all of the interesting security email features. But it's just difficult. Realistic, I think, honestly, there was no way we were ever going to get that done in a year because it's just a big project. And so we should have asked for more time, and we should have asked for more money. I don't know if we would have gotten it.
Okay, so next one. What will be the future of Mailpile?
1.0. No, the future is the next goal that I have in mind is to ship something that is easy to install and use on the Linux platform. So for those of you unfamiliar with the project, our main goal is to ship a desktop client, something people can run on Windows, run on the Mac, something that they can use, something that the end user can use, like the Firefox for email. But we aren't going to get there in one jump. we did try. For a while, we had a Windows version and a Mac version and a Linux version. And we discovered that platform integration, making sure that the metaphors of the OS X desktop are adhered to. We didn't do that. We just got something to run, and users were confused. They couldn't figure out how to start the program or stop the program. So we're postponing that. We just wanted to get the basics out there so that our community can at least install it on a Raspberry Pi or on their Linux machine. And then once that's starting to stabilize, then we'll move on to the desktop platforms. So still working. We do still have sort of a roadmap and a plan.
Okay, so now the question about some psychological aspects. How do you manage stress? How do you prevent burnouts? What keeps you motivated?
Failed at that too. Had a bit of a burnout last summer and the summer before that. It's really hard. And this is one of the risks, this is one of the main risks of being sort of self-employed is it's not a day job that you just go to and then you go home in the evening. You're always at work. And I don't have an easy answer, but take a vacation, do something else. Sometimes what I've done is I've just gone and written something else. I've taken a break from these projects and I've worked on some side project because I love to code, and exploring some other project for a couple of weeks. It makes me feel guilty, but it recharges my batteries. So if anyone has good ideas, please share them with me afterwards. I could use some help here.
Okay. Was there someone who stole your open source idea?
Who stole?
Who stole, yes.
Is that even possible? I don't know. I don't think so. I've seen one instance where there were some striking similarities between the feature set that ngrok offered and what PageKite was doing. And they started a fair bit later. So I do hope that they took some inspiration from what I was doing. But I'm not going to say that they stole the idea. Once you're working on that kind of problem, it's an obvious solution.
Okay, so kind of similar question. What to do in case someone takes your open source project, rebrands it, and starts selling it, violating its license in process?
Are you if this is a question about how I enforce my licenses, I haven't been in that situation yet, so I don't know. I would probably contact the FSFE or the FSF and ask for help. Or the Software Freedom. There are organizations that can help with this sort of thing. SFLC. Software Freedom Conservancy for the people in the stream. But yeah, at the moment I just don't worry about it. And this is one of the advantages to using a liberal license is that you've just given people permission and you don't care. That's what I'm doing with the more recent PageKite developments is the of that code is just under an Apache license. People can use it for whatever. With Mailpile, I'd be very surprised if someone tried to steal that and embed it because it would be so obvious.
Okay, so we have 2 minutes left. The next question. How did the "we lost a day's worth of email" thing went down?
Luckily, we were bouncing the emails, so the senders did get error messages, so they at least knew that they should resend. It wasn't just into a black hole. But yeah, I think our clients were unhappy, and this is one of the benefits to working for a business that had other employees, that there was a marketing guy that could talk to them. I mean, mistakes happen, and it was embarrassing, but we didn't lose the contract. They stayed with us for a while longer after that. I think when we eventually lost the contract, it was just because of some of the problems I mentioned before, that it wasn't a good fit for what people wanted. Rewriting people's emails is confusing.
Okay, so one last question, because we're running out of time. Have you ever localized a program into Icelandic?
Oh yes. I worked on translating KDE back in the 1.1 days, and also done a little bit of work on Red Hat. For a while I was spinning my own Red Hat distribution and mailing it to people in Iceland. So So I made sure that it had translations, and I did some of the translations myself. Mailpile is mostly translated into Icelandic. I think internationalization is really important because Iceland is a tiny community. It's 300,000 people. If we want our software to be in our language, we have to do it ourselves. And this is one of the values that free software offers to smaller nations, is that they can be independent with their computing without having to invent everything themselves. So yes, it's a great way to get started on an open source as a contributor, because you can just sort of read through the code, you can try and understand it, you can translate to your language, and it's a very valuable contribution.
Okay, thumbs up, so thank you for your talk. He's doing a lot from what I see here. So he's a request core contributor, URL lib3 core contributor, and the lead maintainer of the Hyper project, a toolbox of projects for working with HTTP and HTTP/2. And his talk will be building protocol libraries the right way. So let's give him a warm welcome.
All right, first question. Is my microphone working? Yes, there are people waving at the back. Good. Excellent. Hello, everyone. This is incredibly exciting for me. This is my first time in Slovakia at all, so I'm super thrilled to be here, and I'm really excited by how many people showed up for a talk with such an uninspiring name. It's all really good. So, yes, my name is Cory Benfield. I'm a London-based software developer, and taking a cue from Bjarni, I didn't do what Bjarni did. I made free software my job by getting employed at a megacorp, which I can highly recommend, so long as the corp is big enough that you can hide and no one asks too many questions about what you're doing. And I work in Hewlett-Packard Enterprise's upstream team, collection of about 12 people who all do roughly what I do, which is hide and hope no one asks questions. Our job is to work on the projects that Hewlett-Packard relies on from the open source and free software communities, making sure that they are maintained and forward-looking, they get new features, and in particular, our remit is to be building things that Hewlett-Packard doesn't know it needs yet, which isn't that hard. Hewlett-Packard is very big. For me, this means Python HTTP. This is why I was hired in, and this is what I do. The number of projects I work on is unreasonably, grotesquely large, and I'm not going to list them. The core ones, the important ones, are the Python Hyper project, which is a collection of tools for working with HTTP. It's a little toolbox of things that you can put together if you need to build something specific. I work on requests and URL lib3. I've been a core maintainer on both of those for about 3 years now. Requests, I suspect most of you have heard of. Can I get hands real quickly? Yeah, okay, most of you. URL lib3, most of you probably haven't heard of. URL lib3 is the library that powers requests. So you all have it, you just don't know you do. And it's pretty great too. I also get to claim that I'm part of the Python Cryptographic Authority because I have the commit bit on PyOpenSSL, even though mostly what I just do is say, yes, Hinnock, this looks like good work. So, moving on. The original title of this talk, I never actually submitted it with this, but the original title of this talk was going to be Why All Your Libraries Are Garbage and All But One of Mine Are Too. This title is a bit too combative for an actual conference schedule, but I wanted to put it up here to highlight something really important about this talk. I'm going to be talking about a systemic problem in the way we build open source Python network libraries. But I'm not criticizing or blaming anyone who has built such a library. This is not any of our faults. This is a cultural problem that exists in the community. It is bigger than any of us. If you pick up and build a library like this, you will almost certainly fall into the trap that I'm about to describe, and that's just nothing to do with you. I did it too, all the time. I've done this right exactly once, and I've been doing this a little while. All right, so I'm going to talk about HTTP for a while, because this is all I think about. But I think we can agree that generally speaking, working with HTTP in Python is pretty excellent. As languages go, Python's got one of the greatest HTTP ecosystems floating around. You can make some arguments for Go, you can make some incorrect arguments for Ruby, but generally speaking, Python is pretty good. And the reason it's good is because we've developed this really great collection of tools and libraries that exist in the third-party ecosystem. We've got the client-side tools, things like requests and that set of things. People who don't know about it, HTTPIE, I've never known how Jacob likes that being pronounced, is basically a curl replacement written in Python that does highlighting of its output. So if you work with things that return JSON, it will automatically pretty print and highlight the JSON. It's extremely convenient. We've got great pure Python web servers like Green Unicorn, and then we've got all these great asynchronous tools. We've got AIO HTTP, Twisted, Tornado. These have all got clients and servers in them. They're all great tools. And these, plus the many, many tools I haven't mentioned, cover an enormous variety of use cases. They cover clients through to servers, through to proxies. We cover things that provide really convenient APIs to make it easy to do the right thing. We provide things that have all the switches in the world to make it easy to do the wrong thing. There's lots of different options you've got. But every single one of these things suffers from the exact same problem. And that exact same problem is that they basically don't share any code at all. There is obviously a caveat here. They're written in Python, right? So they share the standard library. They all use the collections module, probably. But that's kind of trivial. What I mean is they don't share any HTTP code. Now, I suspect most of you haven't thought about this, but at first blush, it seems kind of odd. I mean, we generally, as a community, agree that code reuse is good. People at least claim code reuse is good, and if someone asked you on a test, you would say, yes, code reuse is good. The reality of it is a little bit trickier than that, but generally speaking, code reuse is good when you have a problem that has a really well-defined scope and one right answer. If your problem has got multiple right answers, you might need to write multiple versions of the code to get the different answers out. If the problem has got an unclear scope, you might need multiple versions of the code to deal with the varied scopes. But when you've got a very clear scope with one right answer, you really do only need one good implementation of the code. Some examples of problems like this are network protocol parsing, turning an HTTP message from a stream of bytes into some representation of that message. There's only one right answer to that. And it's very, very limited in scope. It only happens in one place. Other similar problems, compression algorithms are exactly like this, and file formats, with the possible exception of PDF, are exactly like this as well. There is only one right answer to them. With PDF, there is no right answer. You cannot parse a PDF file, it can't be done. So given that HTTP message parsing, this strictly defined problem, can only be solved one right way, why don't our libraries share any code for this? Why have all of our library authors gone away and written their own? Well, I'm going to tell you right now, it's not because they didn't like the ones that were already there. The reason they've done it is because every HTTP parser in the Python ecosystem, every single one of them, mixes its I/O in with its parsing. Just quick examples from the set that I've used. HTTP-lib, this is the parser that requests users under the covers. It's terrible. It has its state machine and its parser mixed in with its I/O. What I mean by this is the bits of code that parse the HTTP message have got socket calls interspersed in and around them, and those socket calls affect the way the parsing works. The parser will increment some amount of time and then decide it needs more data and wait for it from a socket library. This is an extremely toxic anti-pattern because it makes it very, very hard to get the parser out in a way that allows you to reuse it somewhere else. If you don't want to use those socket calls, good luck trying to get the parser out. For those of you who care about network protocols, the state machine is the other important thing, and the state machine in HTTP-lib is even worse because it is an implicit state machine. There is actually no code that is just state machine, which makes it almost impossible to extract the state machine from HTTP-lib. The only plus point to all of this is that you wouldn't want HTTP-lib's parser and state machine even if you could get them. The various async modules have a similar problem. They're usually better about their I/O because of the way they're structured, but they still usually commit a different sin, which is that they mix their async primitives in with their parser instead. So instead of making socket receive calls and to grab data, they instead wait for a deferred, for example. And that's fine, except if you're not in twisted, you don't have a deferred, and so you can't wait for it anymore. So you need to rewrite all this code anyway in order to strip all that out and put in your thing of choice. Because you can't pull this parser out, you end up with this Python feeling that I think we've all had, which is that once you've chosen how you want to do I/O in your application, you rapidly find that what looked like this enormous collection of choices becomes quite a lot smaller. If you have decided that you like Tornado, but you also have decided that you would like to make your client calls with requests, well, good luck. You're either going to become very familiar with Tornado's thread pool, or you're going to just have to do something different. You don't really have an option. And so now I feel, settling over the room, the question of who cares? Why does this matter at all? So we've got a lot of HTTP parsers. The world is not going to end just because of this. Well, there are some real problems because of this. The first one is that we are wasting our time. And I feel like everyone in the room dislikes this notion of when they have to solve a problem that has already been solved again. And we're doing a lot of this. AIO HTTP, the async IO HTTP asynchronous goodness thing, is the new kid on the block. It's only been around a couple years. And so they were coming into this space that had a lot of HTTP tools in them. Did they really need a new parser? Was the parser the thing they were trying to solve? Was their problem none of the parsers are any good? The answer to that is no. The problem was nothing used yield from, which they really wanted. And in fact, not only did they have to write their own parser here, they don't like their own parser. It's not very good. This is not their fault. It's hard to write a good parser. It wasn't the focus of their time. They're looking to replace it. But of course, they're looking to replace it. There's still nothing else they can use. The request team use HTTPlib. I've just been very mean about HTTPlib for the last 5 minutes. And if you'd like to come and talk about how bad HTTPlib is, I'm happy to tell you. I've said that request uses HTTPlib. It's not even really true. We've monkey patched about a half of it. And at this point, it looks nothing like the actual HTTPlib. And we'd much rather not be using it. But there's nothing else we can use. And this happens every time someone builds a new HTTP library in Python. Every single time. They have to write a new parser, or they have to conform very tightly to the one that's already there. They have to, and this is a follow-on problem, because it reduces experimentation in this space. I don't think, hand in the air, as a requests developer, I don't think requests is the end-all, be-all of API design. I think there is room for alternative API design approaches to HTTP, but they're hard to do, because if they are going to diverge very substantially from what's already there, it becomes difficult, if not impossible, to actually make the code work, or you have to write your own parser, which is not what you wanted to do. You just wanted to play with this new API design idea. This gets even worse if you're the kind of person who cares about doing I/O. If you wanted to play with lots of different I/O ideas, then you are absolutely out of luck. You just definitely will have to write your own parser. There's just no option for you. And this is totally unnecessary overhead. There's only one right answer here. Why are you solving this problem again when you didn't need to? There should be no requirement on you to solve this problem. But probably the worst is that this causes us to duplicate our bugs. HTTP looks very simple to parse. How many people in here have written HTTP parsers? Hoping I'll get at least one hand. I've got 2 hands. That will do. Both of your parsers are wrong. And I don't mean this in like a mean way. It's just parsing HTTP right is really hard. My parsers aren't right either. I should put my hand in the air. The only parser I've ever used that was right was not written by me. It is almost impossible to do correctly. The protocol is very, very ill-defined, very hazy, and then you have the problem of whether you're parsing the protocol as written or in the spec, or the protocol as used on the web, which is not the same thing. And so we make bugs. This is just what happens. Bugs enter these libraries, and then they enter the same the parsing library in a different library altogether. Chunks transfer encoding. There are bugs all over the place, and we keep bumping into the same ones in different libraries and fixing them again, which compounds our wasted effort. And then one more, which is one I think people often don't think about. It limits your ability to optimize your I/O. Most people don't think about this, especially in Python land, because we write in Python, a language where optimizing our CPU time is frequently more important than optimizing our I/O. But optimizing I/O is a real thing that you can really do, and it's hard. It's really, really hard. And that causes a problem if you can't get at the I/O and pull out the bad solution that's already there and put in one that's tailored to your problem. If your I/O is very tightly tied to your parser, then your parser is informing your I/O strategy, which it should not be doing, and it's limiting your freedom to change the way you approach I/O. So hopefully I've convinced you that this does cause real problems. None of them are earth-shattering problems. None of them are preventing us getting our work done, which is why, generally speaking, this does not get talked about. This is not a problem like bad TLS configuration. This is not a problem like the API literally does not allow me to achieve my job. It's a problem that says, you're wasting some time, you're wasting some money, we could be doing better here. And we can be doing better here. This is a problem you can avoid. And avoiding it is just really, really easy. Don't do I/O in your parser. Just don't do it. If you're writing a parser for a network protocol, for a file format, anything like that, just have a rule. No I/O. Don't import the I/O library. Don't import the socket library. Don't use the keyword open. Don't use any function called read. Don't use a function called write. There's probably some good other ones too. Don't use a function called print. That's a good one. Don't print things. It's tempting to print things. Don't print things. Don't do I/O at all. You should be possible for you to build a 100-foot high wall between the bit of your program that does I/O and the bit of your program that parses a file format or a network protocol. They should know nothing about each other. And if they do know nothing about each other, then you can pick that parser up and use it somewhere else. If you decide to rewrite a whole swathe of your application, you don't need to rewrite the parser because you got the parser right the first time. There's only one right answer here, and you hopefully have tests, and so you know it's right. If you get this wrong, even just a little bit, it dramatically increases the amount of work you have to do to reuse the work you have already done. And to be really helpful, I'm going to give you an example of how this should look. This is a much better API for building network protocol parsers. You get one function that looks like the thing on the top. This function takes in data. It doesn't care where the data came from. It doesn't care how the data is broken up, unless that is meaningful in your protocol or file format, which it can be, but usually isn't. It just gets some data. And then it returns what I'm calling events. This is a slightly tricky thing. We don't actually have good terminology for what this is supposed to be. I like to call them events in C land, where they have not made this mistake. Frequently, this actually involves invoking callbacks. But what happens is the function tells you, given the bytes I just received, here are all the things that happened on the network protocol. In HTTP, this would be things like, I received a request, or I received some data, or the connection went away, or I received some chunk transfer encoding trailers, which is a feature no one supports. This kind of thing, this abstract representation, for file formats, you would probably want to go a little bit differently. Depending on the format, you might actually need to be incrementally building up a tree. This is a slightly trickier thing to do, and I'm not going to talk about it too much more, but the general idea is still sound. You say, you gave me some data, it had these things. This data might have had the beginning of more things, but they're incomplete, and that's fine. There should be some buffering internally. Once the caller has given the bytes to the function, that should be the end of those bytes. They should be able to forget that they ever existed. Then symmetrically on the other side, you have a series of functions that look like the bottom. For each event that can happen, it should be possible for the user to trigger that event. And they should do that by calling a function and passing any of the associated metadata they need. HTTP, you can receive a request. Well, you should be able to send a response. So you have a function called sendResponse. What do responses have? Status codes, reason phrases, headers. It takes all of those things too, and then it returns some bytes. Just some bytes. Once that's happened, the protocol parser has washed its hands of the situation. It is done. That's its job. Over. Here are your bytes. The key here is the protocol parser doesn't care where the bytes come from, and it doesn't care where they go. This is great. This lets you swap out your I/O implementation altogether. Do you want to write HTTP to a file? Fine. Go nuts. You just change where you're writing your output bytes. Everything gets pretty easy. The goal is you just don't care where the bytes come from or where they go. This does not solve all problems. I should be clear. Particularly with network protocols, there are often things that cannot be done automatically. They require user input in some way. HTTP 2 is problematic for this. It has this notion of flow control, which allows you to control how much data the sender is allowed to send you at any one time. Obviously, the parser should not be making flow control decisions. Parser is not in charge. In this kind of situation, your parser should make it possible for the user to make those decisions, and should probably have in its documentation, which all your internal code should be having, it should have a little thing in the documentation that says, here's how you do it. These are the events you will get. Here are the responses you should be making. Once you've done this, once you've got your little protocol parser, the real thing you do is you build wrappers for it. You wrap it in a higher level library that does know how to do I/O. I want to stress here that I'm not saying that requests shouldn't exist or that Twisted shouldn't exist or any of the high-level libraries shouldn't exist. Of course they should exist, they're great. I don't expect you as a web developer on a deadline to start writing, to pick up my protocol parser and start writing an HTTP implementation from the ground up. That's crazy. But what I do expect is that when you pick up requests, requests should not look like it looks now. It should not be a stack of libraries all the way down to the bottom to the socket calls. Instead, requests should have a protocol parser somewhere over here and an I/O layer somewhere over here, and it should mediate them together. Requests should be API and I/O. Ideally, it shouldn't even be I/O, but that's a different talk. It should be API and I/O. The protocol parser should be exactly the same as the one AIO HTTP has. AIO HTTP should be using exactly the same parser with a different API and a different I/O layer. That would ideally mean in a world where you had lots of things installed in a virtual environment. If you update your parser, everything gets bug fixes all at once, like magic. Someone in the Linux community told me that shared libraries are a thing that used to be a good idea. Perhaps, maybe there is some value here. What you want is to have one parser with two very different feeling libraries. There are some advantages to developing this way for the parser as well, and the big headline one is that testing it is so much easier. Who here writes tests for their code? Not every hand has gone up, which makes me a little bit nervous. How many of you who didn't put your hand up make a product that you sell? Cool, I've got one hand, two, okay, I've got a couple of very nervous hands. That's good, I just want to know whose product I shouldn't be buying. Testing's important. I think even those who didn't put their hands up can agree that testing is important and a thing you should do, even if it's not always a thing you do. Testing libraries, testing anything that does I/O is hell. It is the worst thing to do in the world because your I/O logic is inexorably mixed in with the logic that makes other kinds of decisions. You can't test HTTP-lib's parser without also testing its I/O because they're the same thing. And so you need to send all the data in through wacky socket messages, and now you're mocking out sockets, and then all of a sudden you have to start testing every possible timing issue that could ever happen on a network protocol layer to make sure that HTTP-lib does the right things in the right places. And that's crazy. It is an impossible thing to do. With the new model, where the parser is just function calls, testing it's stupidly easy. We all know how to test function calls. And you get to start doing some of the really clever things. So this up here is a library I work on, the only library I've ever done this right with. Those are the tests from a couple months ago. It had about 500 something. What that's not showing you is that about 20 of those tests are property-based tests using the hypothesis testing library. That means that it tests the same function, does something sensible with hundreds of different kinds of input. So actually there are more like 1,000 tests here where 20 or 30 of them are written in such a way that they run 100 instances of themselves very quickly. Additionally, you might want to note the tests are altogether pretty fast, and they don't spuriously break from time to time. There are no timing issues here that can cause your tests to mysteriously fail. If the tests fail, something has actually gone wrong. And then, ideally, it allows you to make some really nice assertions about what kind of code is reachable. Because data can only get into the parser in one place and only out of the parser in a specific set of places, it's very, very easy to work out whether or not your code can be reached. If there is no possible input of bytes that can reach a line of code, then that line of code is superfluous because no set of input of bytes can ever get there. This makes it very, very easy to write a library that is relatively concise and fairly easy to test. This is all really good. The other little one that I think people forget is, again, the way you do I/O matters very much. How many people in here have written anything that calls into the socket library? I'm not expecting many hands. Quite a few of you. All right, how many of you can recite for me now every socket flag defined on Linux and what it does? I've got no hands for the stream. This is good. This is because, of course you don't know that. Why would you know that? This is a ridiculous thing to know. But there are people whose job it is to know that. They're the people whose job it is to take an already high-performing application and squeeze an extra 20 requests a second out of it. And they do that by caring very, very deeply about the I/O on their platform of choice. It is hard to write a high-performing I/O stack. It is hard to write a good parser. Expecting someone to have both of those skills at the same time is ludicrous. If you find such a person, hire them immediately and never let them leave. There will never be more than a couple of those in a generation, and I'm definitely not that good. If you don't have to solve a problem, don't solve it. If you don't have to solve your I/O problem, if you don't care about how fast your I/O is, don't make those I/O decisions for other people who might care. So it is just solve one problem at a time. And then build a toolbox of really great implementations. I dream of a Python world where we had one really good protocol parser. It would be fast, it would be correct, the code would be relatively clean. And the reason that would be the case is because all 200 people who work on open source Python HTTP would be contributing fixes to the same library, because it matters to all of us. But that's not the world we have. Instead, the world we have is where the async I/O people contribute fixes to async I/O, but never to requests, because they don't care. And that's unfortunate. More manpower would be good. We need to make it possible for us to work together in a more effective way than the way we do it now. And having these silos doesn't help. It then frees up the 80-odd developers on each project who don't care about the protocol parsing at all. They care about I/O or they care about API design. They shouldn't have to think about parsers. We should be freeing them up to do what they're good at and letting the people who care about parsers, the weirdos like me, care about parsers. For those of you who feel like this talk was a little bit theoretical, this is the only library I've ever written where I do this right. This is a pure Python HTTP2 protocol stack. HTTP2 is quite complicated. You can go look at the docs and get a feel, particularly the API docs, and get a feel for the way this works. Then I'm going to segue and say, if you are interested in this, and you think it's an idea that you want to investigate a bit more, then you should come along and try and help. I am one person and I can only do so much. So, if you can think of a problem that would benefit from being solved in this way, write something that fits that little API design. It was only one slide, it's pretty easy. Write something that fits that kind of design and see how it feels. See if it feels natural to use it. If you instead want to see HTTP2 in your Python library of choice, pick up HyperH2 and plug it in. I'm going to be around for the next day or so I'll be happy to give you some guidance if you need it. But also, I answer emails. Feel free to get in touch. I have a Twitter account. I'm always happy to help out, and it should be relatively straightforward. I just used all the words for that slide, and I am done. So I am now happy to take questions.
Okay. Your thoughts on wide adoption of HTTP version 2?
I feel like some more detail in this question would be good, but I'll just answer it in general. I think we're already there, actually. HTTP2 is already much, much more broadly adopted than IPv6, which is a win. But in particular, once Cloudflare switched over, I think the statistics are now that roughly 1/4 of web traffic is HTTP2 already. So you're all using it, you just didn't know it yet. If anyone's got a relatively modern browser, you're using it.
Okay, next one. Does HTTP2 spec solve the issues you talk about?
The issues about being hard to parse, I assume, is where that question came from. Yes, HTTP2 is much easier to parse. It is a more complicated protocol from a state machine perspective, but parsing it is trivial, and it's quite easy to write a fairly quick Python parser of it, which is another massive win.
Okay, so the next question, actually it contains a suggestion. Speaking of protocols, can HP dedicate some resources to developing Python's IPFS implementation?
I feel like that's a question that should come to me after the talk, because I can't make promises for HP on camera.
Okay, the next one. How would you approach writing a library for a loosely spec'd joke of a protocol like Bluetooth?
Generously. The answer is it'll take a long time. The goal should be, so the overall design goal should be the same. You get bytes. With something like Bluetooth, which is a little bit lower level, some other problems do start coming into play, and it is much harder to divorce the parsing of such a protocol from I/O. You can usually divorce the parsing. Divorcing the state machine is almost impossible. The best advice I can give is to get the largest corpus of sample traffic you can find and keep testing with it. You need as many possible variations of that input as you can possibly find to use for your test suite and run it all the time, constantly. That is the only way you have any chance of succeeding for a protocol as loosely spec'd as that. The same advice applies to HTTP 1.1, by the way.
Okay, next one. Separating parsing and I/O concerns in request twisted whatever library seems like a natural thing to do. Do you know why devils are not doing it already?
I've got some theories. My theory for things like requests, for the kind of synchronous code flow in Python, is that Python made doing socket I/O quite a lot easier than it was in C. And as a result, it is now sufficiently easy that most developers are inclined to just do it. If you're working either investigatively or to a deadline, you're much less likely to be concerned about your code structure and much more likely to be concerned about how quickly can I get something that appears to do the job. And putting your socket calls in line is a very, very fast way to get to that. That's how I suspect we got there in the synchronous world. In the async world, as I suggested, I think the bigger problem usually actually is they just know a great deal about the way async is done in that particular world. Twisted's HTTP code would not work in async I/O without substantial changes. That's not entirely Twisted's fault. Twisted is 12 years older than async I/O is, but the point still stands. The way it was developed was for Twisted with no particular goal of code reuse, so it just wasn't a priority.
Okay, next one. What do you think about including popular Python libraries, example requests, into standard library?
Oh, that's easy. The requests team has a policy on this. The standard library is where modules go to die. By which I mean the standard library limits the ability of a module to change, and particularly to change rapidly, and to support that change for people who, for whatever reason, cannot update their Python. If you are stuck on Python 2.7, having requests in the standard library would have been pretty terrible for you. Your security would have been really pretty bad for a long time. Anything that touches security-critical code, like requests does with its TLS, just should not be stuck on Python's release cycles. It took so much effort to backport a good SSL module to Python 2.7. The idea of having to do that for requests every time we needed to make a change is heartbreaking. I couldn't possibly bear it. So for things like that, I think staying outside the standard library is the way to go. The agreement we reached with the Python dev team is one you can go and see. If you go look at the documentation for unit test 2, you will notice that not unit test 2, URL lib 2, you will notice that the documentation says right at the top, don't use this module, use requests. We feel like that's probably the right middle ground there.
Okay, and the last question, which HTTP library could be used as a basis for this abstract parser isolated from I/O? Would it be possible to isolate and merge parsers from different libraries?
That is a great question. I'm sad that it came at the bottom, because only one other person in this room is as nerdy as me. On this issue, plenty of you are still super nerdy. I think the answer is, there barely is one. The closest there is there are two wrappers for a C library called Pico HTTP parser, which is used at the basis of the web server H2O. That library is stupid crazy fast, which is why there are two wrappers for it, and it is just a parser. It is probably the only just an HTTP parser you can find on PyPI. So if I was going to start, I would say that that should be the basis, and then we should retrofit a Python-only implementation on top of it. I am currently not volunteering for that work. I have been asked to look at it in the past. I still reserve the right to look at it because I do what I want. But right now it's not, I don't think the trade-off for it is worth it. I think the amount of work required to write it is less than the value we would derive from it, because it would be very, very hard to move all the things that already have working solutions to this new model. In other words, HTTP 1 is dead. Long live HTTP 2.
Okay, so I think that was the last question. So thank you for your talk.
Thank you.
is Daniele Procida. Daniele works at Divio on Django CMS, Aldrin, and other Django-based projects. He also been involved in organizing DjangoCon Europe 2015 and PyCon Namibia 2016. So, big applause to him.
Thank you very much, and thank you very much for inviting me to speak here, because it's genuinely an honor to be here at your first PyCon. Congratulations to the Slovakian Python community for this superbly organized event. I'm really impressed by what I see has been achieved here, and I think the fact that your first PyCon has brought more than 400 people in is a really encouraging sign for the Python community and industry's future here. So congratulations to all of you for that. And I have to start with an apology because I'm doing the wrong talk. I'm really sorry about that. I realized at about 9 o'clock yesterday morning that the talk that I said I would do wasn't the one that I've been busy preparing for the last few months. So anyway, speaking of how well things are organized. So I hope this is not too much of a disappointment for you. My name is Daniele Procida. I'm the Community and Documentation Manager at Divio, the Swiss Django company. I'm a developer of Django CMS. Does anyone use Django CMS here? Oh yeah, there's always a few people. Thank you. I'm a core developer of the Django project. Sorry, I work for Divio. I'm a core developer of the Django project. I'm a board member of the Django Software Foundation too. And you can feel free to contact me anytime on various electronic places. Okay, so what do programmers actually like? Now, I probably don't need to tell you that there are all kinds of stereotypes that surround programming and programmers, and some of them are fair enough, and some of them most definitely are not. So, you know, programmers, yes. All they do is watch science fiction films and listen to heavy metal. So, programming has a reputation for being a mechanical, unimaginative discipline. And I think that's actually really unfair. Because if you're a programmer, you'll know very well that a programmer's work can bear the imprint of a programmer's creative personality just as much as any other writer's work. But good luck explaining that to a non-programmer. Good luck explaining that one of the pleasures of programming is a creative pleasure. Now, I have always myself found pleasures in seeing and understanding and playing with patterns and rules and connections in language. And that pleasure feels similar to the kind of pleasure that I have in programming. I think many other programmers also experience this. And I think that in some ways, what programmers like doing with language is quite similar to what poets like doing with language. Now, I'm going to just skip over a couple of sections here because I don't think we really have time for this. We can talk about this later. But there are some things that programmers and poets both like doing in different ways. In fact, artists of all different kinds like to do these things. So taking language and turning it back on itself, referring it to itself, taking it apart to see how it works, finding in it elegant, economical, powerful principles, explaining or exploring patterns and rules and connections, putting it together in new ways and extracting new meaning. Now, poets and other writers do this. I don't want to say that poetry or art are the same as programming, or that a good programmer will be a good poet, or vice versa. They're not. They're completely different disciplines. Programming is not art. It's not poetry. But they meet and they have connections in some notable places. One of them is the kind of sense of humor and aesthetics that programmers have. There are certain jokes and kinds of playfulness that programmers will get straight away, and you know when you have one of those jokes that the programmers you know will enjoy it. In particular, programmers seem to be fascinated by rule-governed play. We'll talk more about this. And they respond strongly to it when they find it, not just in programming, but in poetry, music, and art, and so on. And so there are some notable writers and artists whose work and ideas speaks to programmers.
I think it's the way that programmers think that makes them especially ready to understand this intersection of rules, processes, and play that characterizes certain kinds of art. And even if the thing that you're looking at has nothing to do with programming, often you can see something in it that you know will appeal to programmers. Programmers also love systems, and three of the things they love best in systems are also things that are very interesting outside programming: loops, self-reference, and hierarchy. So we'll start looking at some of these straight away, starting with loops. Years ago, I found a website called TextArc. Does anybody remember TextArc? Okay, it's an ancient website, about 15 years old, written in Java. And I spent a lot of time in this website 15 years ago. It's quite magical and quite beautiful. And it shows you one of the things you can do when you loop over text with code. Now, I have to do this in a very old version of Windows, because the Java is so old I can't get it to work on my Mac. Now, let's hope this works, because I never have very much luck with this, okay? So it's going to take the text of Alice's Adventures in Wonderland, and it redraws it twice in a circle, and then it shows you the relations between the words. It's actually kind of reading the text right now. But we can go and find a word, so I can't really see things too well. We could find a character. So if in the middle here, for example, you'll find things like Alice should be somewhere in the middle because she's represented right the way around the circle. But somewhere over here should be, I can't actually see that. The dormouse should be around here somewhere, because the dormouse is in that sector of the story near the beginning. So you can find anything and see what it's connected to. You can put any text into this and play with it in different ways. Look at textarc.org and spend some time in it. It's wonderful. And let's, well, I can't even see it properly, so I'm just going to go back to my slides here. But that's one of the things that started making me think a long time ago about some of these ideas. So one of the things you lose in TextArc is a sense of the content. You don't get the content anymore, but you get its structure presented as its metadata. So why do structure and metadata matter in text? Well, we've thrown out the content, or it's no longer visible to us. But we also gain something else because we see new meaning that perhaps was previously obscured. And when I say see, I mean literally see, because in that visual representation, you can see things in a way that you can't when you're reading the text. We can see who is associated with whom. We can see who appears when and with whom. We can see who dominates the story. And we can see this literally. So don't be distracted by the fact that what TextArc does is amusing and literary. It's also powerful and significant, and this is not lost on large corporations and government agencies who also understand the power of those relationships, that's structure and metadata. They know what those things mean. In various countries in the world, right now, or recently, or in the future, there are governments anxious to have legislation enacted that will give their agencies the right to similar information about our communications and activities. That is the metadata, the structure of our communications and activities. And they'd never do anything like eavesdrop on their citizens, listen to their conversations. They only want the metadata. They don't want to spy on our lives. So don't worry, our privacy is safe and assured. I hope you can read that from the back, but this is basically the idea that here's the politician trying to reassure people that recording metadata keeps you safe. Well, in fact, we know an awful lot just from metadata, even if we don't know anything about what's being said. Just this morning, I saw this. Yeah, of course they can. They can visualize information to find out what's going on without knowing what that actual information is, but just looking at its structure and metadata. So this is, of course, interesting to programmers and has implications beyond programming. Now, if you noticed on TextArc, the other text at the top was Hamlet, Shakespeare's Hamlet. It's not there by chance. For whatever reason, Hamlet is one of the texts that people go straight for when they want to start doing this kind of work with texts, when they want to start exploring text in this kind of way. And Hamlet brings me to Ulises Carrión. He was a Mexican artist and writer. He died quite young. A lot of his work was concerned with playing with texts, manipulating, analyzing, deconstructing, synthesizing them, often by following simple rules. And I mentioned earlier that programmers will really get something, and this is an example. So I'm going to play you one of my favorite pieces by Ulises Carrión. The first time I heard it, by chance, I thought, what the hell is this? And when I realized what I was hearing, I just burst out laughing in recognition of its simplicity and logic. And when I play this to other people, that's their same reaction. But then it divides the world into programmers and non-programmers, because the non-programmers are irritated and baffled. They say, what is the point? The programmers suddenly start smiling and laughing. I'm not saying that every actual programmer, I'm talking about people with the souls of programmers. So there might be some people who are not programmers who have the souls of programmers, and vice versa. So anyway, this is, here's Hamlet. And here's Ulises Carrión's Hamlet for two voices.
Bernardo,
Francisco,
Bernardo,
Francisco,
Bernardo,
Francisco,
Bernardo,
Francisco,
Bernardo,
Francisco,
Horatio,
Marcelos,
Francisco,
Marcelos,
Francisco,
Marcelos,
Bernardo,
Horatio,
Bernardo,
Marcelos,
Bernardo,
So
Marcelos,
can we turn the sound down for a moment? I
Bernardo.
can't stop it here.
Horatio,
Bernardo,
Marcelos,
Bernardo.
Okay. So anyway, I think this is funny. I think it's hilarious, but it's not just funny. It's a new interpretation of Hamlet. Hamlet for two voices, left speaker and right speaker, without any content. We have only the structure. We've lost all the content. You won't know that Hamlet is a story about revenge, murder, or desire. You won't know that Hamlet is a prince or that the story is set in Denmark. But there's a lot to learn. We can learn from that, which, by the way, lasts about 15 minutes. We learn who is still around at the end of the story, which is not a given if you're in one of Shakespeare's tragedies that you'll still be around at the end. We can discover whom the story revolves around, who dominates the conversations, who hangs around with whom. We can guess who is conspiring with whom. You know, governments would love to know that. Yeah? Just like government agencies. So there's new stuff.
Bernardo.
Oh, sorry. As I say, I really love this in the same reason that I loved TextArc 15 years ago. But 15 years ago, I wasn't a programmer. I'm a programmer now, and when I see this kind of thing, what I think is what I know you're also thinking. Key value pairs, looping over a sequence of key value pairs. I played this to my colleagues a few months ago and had exactly the effect I expected, because they're programmers. I got this a couple of days later in instant messages. And I did a little work on it myself. And so let me show you some Python. Okay, so here's a bit of Python code. And we go to a text source. We use request to pull it down. We put it into beautiful soup. We loop over it. And then we call the OSX say command. So
Bernardo,
Francisco,
Bernardo,
Francisco,
Bernardo,
Francisco,
so this is my
Bernardo,
Hamlet
Francisco.
for two voices
Bernardo,
being performed
Francisco.
by
Bernardo,
Python.
Francisco,
Horatio,
Marcellus,
Francisco.
So that's, you know, I was quite pleased with that. That's quite simple, but that's quite fun. So computers are the perfect tools for this sort of play, this kind of exploration, analysis, or discovery. And if you're interested in it, it's everywhere and very accessible. You can, there's a whole field of experimental literature that's ripe for this. The Oulipo group, the Au revoir de littérature potentielle, the workshop of potential literature, a French group of mathematicians, artists, and writers who play these kinds of games. We don't really have time to talk about this, unfortunately, but ask me afterwards, because their work is ripe for exploration in programming. Or if you want, maybe, has anyone read Microserfs by Douglas Copeland? Yeah, so here, it's just 2 pages in the book where the text has been divided into consonants and vowels, you know. What happens when you do this? So people are playing these kinds of games, not just highbrow literary experimenters, but also popular novelists. We can play endless games of this kind. And I've been talking about games and playing, and some of it's a lot of fun, but it's also very serious, because play doesn't just mean fun. Play is the looseness in a mechanical connection, the extent to which one side of a link is not determined by the other. Has anyone here driven a 1970s Datsun or an old car? Because you might find that there's a lot of play in the steering mechanism. That's what we mean by play, where that part where there's a looseness in the middle. It still works, but there's some play. So, but play depends upon a linkage, a connection, or a constraint. If there were no constraints at all, there couldn't be any play. So it exists in the context of constraints and rules, where the joints or the rules permit some limited movement. If there were no play at all in a mechanism, then the whole thing would be completely locked and it wouldn't be able to move at all. You know, think about gears if there were no friction, if there were only friction and no play. And the rules and connections in language are just open and loose enough to allow both for rigorous meaning and play within the same system. So play of this kind is enjoyed by artists and writers just as much as programmers. And I want to play you another recording by Ulises Carrion, which is his first Spanish lesson. Again, I heard this on the radio the first time I encountered him, and first I was puzzled what I was hearing, and then completely overwhelmed by what was going on. So very briefly, in case you don't know Spanish, Español is Spanish. Es means is, or is it, so you can say es verdad, is it true? Es verdad, it's true. So that's just, that's enough for you to understand this. So let me play you the first Spanish lesson of Ulises Carrion.
Español, español, es español. ¿Es español? Sí, es español. ¿Es ese español? Sí, ese es español. ¿Es ese español español? Sí, ese español es español. ¿Es ese español español? Sí, ese es español es español. ¿Es si es español español? Sí, si es español es español. ¿Es si es español español? Sí, si es español es español. ¿Es si es español? No, si ese no es español.
And so on. So I could hear people laughing. I've played that to people, obviously people not with the souls of programmers, and they said, this is a really shit way to learn Spanish. And I've played it to other people, writers, said, this is awful, I don't get this at all. I think, well, there's something missing in you're not getting something really important there. So I love this. It's fiendish, it's maddening. It's language about language, that it loops over its own structures. It recurses on itself. It's language that eats language. Now, usually when something consumes itself, it reduces quickly to nothingness. But in this case, something new and strange and magical comes out. And it's a perfect example of playing with rules and processes. And as a programmer, it makes me itch. It is a program in a way. It's following its own logic, obeying its own internal rules. And I loved it 15 years ago, even when I wasn't a programmer. But when I look at it now, what I think is, could I create a first Python lesson on the same basis with some Python code that feeds into itself? I actually had a little go at doing this. I didn't get very far, but the rules are very simple. You interpolate self-similar fragments, you corrupt fragments when you're searching for validity, whether it's is Spanish or is actual Python. You can drop and add and move fragments around. You can seek homophones, words which sound the same, or new words that are constructed. You evaluate the validity to a binary value and then feed it back into itself. So, really we have the technology. You can give a string, you can feed it to KWList or built-ins or run eval on it. I didn't get very far with it because I got distracted by making a Raspberry Pi represent the characters in Hamlet with flashing different colored LEDs, so that's as far as I got. I will return to this one day. But we started with loops just like Nick mentioned. Of course, everybody does. Even the simplest loop represents power. It doesn't matter how trivial the loop is. It unleashes an infinite sequence, and then we'll try to make that real. And there are many constructs in programming, but the one I love the best, the one that seems the most beautiful and powerful, is the loop, because loops, they're perfect and they're simple. But, the fascination of go to 10 is rather limited. Go to 10 is only interesting for being infinite rather than for anything that comes out of it. It's not about anything, and it's always the same. It's when self-reference gets added to the loop, as in the first Spanish lesson, that things get really interesting, because then you get this loop of self-reference, of something feeding on itself. So one day I might make more progress with my first Python lesson, this loop of self-reference in Python, and I might build my snaky self-referential loop. But snaky self-referential loops have been around for a very, very long time. Nothing's really new. The concept of a snake that eats its tail is much, much older than somebody imagine a Python snake eating its tail. This is the Ouroboros, the very ancient symbol in many cultures of renewal and regeneration. It represents a kind of impossible magic to make something that eats itself. But sometimes it really happens, like in Ulysses Carry On, when something comes out that wasn't there before. Not just something new, but a new kind of thing. And programmers, as much as artists, are fascinated by what happens when a self-reflecting process loops. And we're lucky because we have the perfect tools for it. Artists have tackled the Ouroboros in their own ways. This is a representation by MC Escher, who was also fascinated by loops and self-reference. And this brings me to someone who I think is one of the most interesting thinkers and writers on the subject, Douglas Hofstadter. His best-known book, Gödel, Escher, Bach, explores art, music, and logic, consciousness, and it's an utterly remarkable book driven by the same fascination with loops and self-reflecting processes. And in the book, he's in search of, his ultimate goal is our own human self-consciousness, which is the ultimate self-reference. I read this book when I was 19, and I was again overwhelmed by it, by its ambition, its intelligence, the creative force that had been put together to make this an actual work. The book itself loops and recurses upon itself and its own structure. And ultimately, Hofstadter is interested in what emerges from simple processes, from self-reflecting loops. By the way, he's a really interesting fellow, and his sense of humor and aesthetics appeals very naturally to programmers. He devised Hofstadter's law, and Hofstadter's law says that it always takes longer than you expect, even when you take into account Hofstadter's law. So, programmers love this kind of joke. So he's interested in the emergence of complex structures and behaviors from simple processes. So emergent properties of systems. An emergent property is one that arises in a system but can't be found anywhere in its components. You can look for the behavior, you can look for the properties, but you won't find it in the components. So sometimes the property is geometrical order. So this is the effect of water erosion. You're not seeing something in the structure of the rocks or anything like that. You're seeing the effect of a process, an unpredictable effect that produces an order that doesn't exist anywhere in the process itself. Another example might be an ant column, where column organization is nowhere to be found in the behavior of individual ants. It can't even be predicted from it, but yet in the system of ant interactions, a column, a new system that didn't exist before, emerges. Or in the art of Bridget Riley, where simply repeatedly following a line produces, through the natural free play of the activity, something that's not in any of its components. Or Google's Deep Dream, that uses iterating patterns and generation algorithms, matching paths to holes, crossing levels of hierarchy, from which new levels of really bizarre significance emerge. Evolution, natural selection in nature, can itself be considered an emergent property out of chemical or biological processes. And because there are multiple levels of hierarchy in these systems, other properties in turn emerge from evolution. They are emergent features of evolution. So there are numerous behaviors observed in nature whose explanations have been sought in emergence. Cooperative behavior is one of these. Why is there cooperative behavior within and even between species when it would seem at the level of individuals there's no benefit in it? This image is a graph from a Python library, Axelrod, and it shows the success over time of generations of strategies in a tournament of the iterated prisoners dilemma. I'm kind of running out of time here, so this is I'll try and wrap up as quickly as I can. This is a search for the secret of cooperation in evolution. And you can do it in Python. Go and have a look at Axelrod or talk to me afterwards. Hofstadter ultimately argues that consciousness is an emergent property that arises from the systems in the brain. First, we discussed loops and the magic that seems to follow when they become self-referential and something new comes out of them. Hofstadter adds levels of hierarchy to this so that we have loops within loops at different levels in the system. And his thesis is that hierarchies of self-referring loops lie at the heart of cognition and consciousness, that the human brain's neurological processes are based on loops, self-reference, logic, play. So it's an explanation for cognition. Consciousness is an emergent property. You won't find it in the neurons of the brain. You won't find it by looking at the components of the brain, but you need to understand the system, what happens in its loops. Maybe this is the origin of self-consciousness as hierarchies of self-referring loops. Maybe consciousness is a system that nourishes itself, apparently impossibly, like the snake that eats its tail, like the things that come out of this level in the two-dimensional level into another level that feed back into each other and feed back across the levels. In fact, one of his later books is called I Am a Strange Loop. He thinks that the eye of consciousness is the process of looping and self-referring across hierarchies. And it raises the possibility of an approach into cognition research and artificial intelligence that's not like some of the ones we see at the moment that are premised on brute force, big data, huge ontologies, but it begins with the simplest of tools, the little tools that we have right here at our fingertips in Python. It doesn't matter whether he's on the right track or not, really. The important thing is to have these ideas and exchanges and to be able to think about these things. And the thing that really delights me, that makes me very happy to be in the company of programmers, is that I find that the poets and artists and writers who fascinate me and the things that fascinate me in programming come back in a pleasing circle to the things that have puzzled me in philosophy for decades. So I'm really delighted to see this snake eating its tail. It makes me feel that in programmers, I'm in the right kind of philosophical company. So that's a quick list of the things that we looked at. Jacqueline, thank you very much. Sorry for going on too much. Any questions?
So the first one is, what's your favorite heavy metal band?
No, I'm not that much into heavy metal, so I couldn't really give you an answer about that.
Okay, next one. How do you encourage play in daily software development?
In a way, I don't think it needs to be encouraged. I think that programmers just do it all the time through their jokes and their little games and competitions. In the Axelrod library, for example, that you've seen there. Now, that's a mathematical research tool. It was built by a colleague of mine at Cardiff University, Vincent Knight. But one of the most active contributors to that library is a 15-year-old boy who's devised strategies that are extremely successful in the evolutionary speaking. And programming is so much about play to begin with that I don't think that it's a struggle to do it. I think that the play is right at our fingertips from the beginning.
Okay, what about the role of bugs in play?
Yeah, the unexpected thing, think about how bugs, a bug is like a bit of free play in your steering wheel, where something didn't quite work out deterministically. And you can go to interesting places. Sometimes you crash, literally, with a free play. But sometimes something new will come out, a direction you didn't expect. And just think how much this happens, for example, if you listen to jazz, when something goes wrong. It's an opportunity to take things in a new direction. So too many bugs and the system breaks down. So you need this very interesting combination of rigor and connection and looseness to permit the free play.
Okay, the last one, because we are running out of time. Have you ever wrote any poetry?
Oh, nothing that I would ever wish to inflict on anyone else. But I'm quite happy doing things like playing with the LEDs on a Raspberry Pi to make them represent Hamlet for me. That's quite enough fun. And doing talks like this, of course.
So thank you very much for your time.
Thank you very much.
And some announcement. You can subscribe for lightning talks in the hall. There's a whiteboard and you can write your proposition for a lightning talk. And now the break. Our next speaker will be Johannes Wachs from Germany. Johannes Wachs is a PhD student at the Center for Network Science at Central European University. He's also affiliated with the Corruption Research Center in Budapest, and he was a consultant for Bond Weaver, a network science consultant. So now let's start the talk, analyzing networks in Python. So give him applause.
Thank you. Thank you very much for having me. Also, thank you for your participation in the survey and the poll, which is still active. Feel free to jump in on that. I see that the vast majority of you have not ever used NetworkX before, which is great. So let me get right into it. First, who am I? I was just introduced, so I'll do this quickly, but I'm a PhD student again at the Center for Network Science at CU in Budapest. It's a great PhD program. If you're interested in the kind of things I'm talking about today, please find me and figure out how we can work together, how you might be able to join our PhD program. There's great funding available, so please get in touch with me. I'm also a researcher at the Government Transparency Institute, which is an NGO. I'm an occasional consultant and freelancer on the side using these kinds of methods, and most importantly for this conference, I'm a Python and NetworkX user in all of these roles. So first, I have to motivate a little bit why networks. So for me, networks are an excellent framework to study complexity in data. So you always hear about how much data we have these days, but almost always it's in this kind of row form, and that's how it's analyzed as well. And I hope that in the course of this talk, you'll see that this network perspective is very useful. So here's another reason why networks are so interesting. You have these great pictures. This is a friendship network of an American high school. These are all 13-year-olds. This is a sociologist did this study in 2001. And can anyone guess what the colors of the nodes represent? So the nodes are individual 13-year-olds, and the links between them indicate friendship. What do the colors mean? Gender, sex, race. So the yellow nodes are white students, the green nodes are African American students, the red nodes are students of mixed race, and you see immediately a big story. You also see gender in this, actually. Within the two groups, you see a split, and that's gender. And that is maybe not so surprising for 13-year-olds. And so that's on the social science end. Now this is the hard science type result, and this actually I think has a nice follow-up to Daniele's talk just a few moments ago, talking about emergent properties in the brain. This is somehow a mapping of the brain and how it functions into a network. And maybe it's not so jarring an image as the social network on the previous slide, but there are significant differences. And this is one way we hope to understand how does an autistic brain differ from another brain. So those are some motivational examples and some quick terminologies to get everyone on the same page. So graphs have two components, nodes and edges connecting them. Edges can either be directed or undirected. The way I always explain this is that on Twitter, I can follow Barack Obama. That doesn't mean he follows me. But on Facebook, if I friend Barack Obama and he accepts, then we are symmetric friends. And how do you deal with networks in Python? There are a few options, but I think the best one out there, my favorite, the one I use almost every day, is a library called NetworkX. And here's the homepage. Let me read their own introduction. So NetworkX is a Python library, is a Python language software package for the creation, manipulation, and study of the structure, dynamics, and functions of complex networks. So what's the story? It was made at Los Alamos, the labs there in 2005. It's very close to the Santa Fe Institute, which if you're interested in complex systems, you know why there would be a connection. And what are the goals? The goals that they state are They want to provide tools to study networks. They want to provide a standard interface suitable for many projects. They care about rapid development for collaborative multidisciplinary projects, as we saw the two examples from very different disciplines. They want to interface to lower level languages for the speed, obviously, and they want to ease, in this big data world, to ease the process of taking in, and we'll see also exporting different kinds of data sets. Basics, how does it work? Well, we import network X as NX, that's the custom. We create an empty graph, and then we add nodes. So we add a node Janusz. We can also add nodes from containers like lists. So we add Sophie and Otto. We add an edge from Janusz to Sophie, and we can also add edges from containers. Nice and easy. What does this look like? In the IPython notebook, you can plot these things. The plotting is on top of matplotlib. It's not great. Most of the visualizations I'll show you later require external software, but that's more because graph visualization is a very, very difficult task. What about with directed graphs? Well, then the only thing you have to do is initialize your graph as a digraph or directed graph, and you have to take care that when you add edges, the order of the tuples matters. So here I've changed the edges, and you see in the visualization little arrows pointing in the direction. And actually, we've done something that we don't need to do. You can just add edges, and network X intelligently adds nodes if they're not already in your graph. So what can nodes be? Nodes can be really anything, any hashable object in Python. They can be strings, floats. They can even be functions and files. So here I've added a node, the NumPy mean function. That is a node in the graph now. And I can also add files as nodes. And both edges and nodes have the ability to store attributes in dictionary form. So really you can create networks out of any kind of data you can imagine. So in the previous slides, we were adding nodes one by one and adding edges one by one, typing them in. That's usually not how we do it, of course. And thankfully, network X handles the following and more very, very well. So you can take in standard files like TXTs, CSVs, JSONs, specific graphs from other programs, graph formats like GML and GEXF, and finally from Python objects like dictionaries, pandas, data frames, lists of lists, etc. Really, there's excellent coverage for this. Here's a quick example. So I have a TXT file, which is a weighted directed format. So it means node 1 has an edge to node 463 with weight 1, and so on. It's a one line to read this in and to create it and to declare it as a directed graph. And you see this is practically instant, and you have your network ready to go. So for the rest of the talk, I'll present a few case studies about how I use these libraries. So the first one is from my job as a consultant sometimes. It has to do with collaboration and expertise in a firm. So a 300-person company wanted to know how their experts were collaborating and how experts were distributed, and they really wanted to see the network structure of this. And what we did is we surveyed employees to find collaborations between employees and expertise. And let me make a quick note here. You don't ask your employees who are the experts or who do you collaborate with. So there's a big amount of sociometry or psychology that goes into these kinds of survey questions. Anyway, we have two kinds of graphs. We have the graph, or two graphs in this data. The graph of collaboration relationships and the graph of expertise nominations. And from this, we create some simple indicators or features. We take the collaboration graph's density. We take, and then we generate an expertise score for nodes using PageRank on the expertise graph. PageRank is basically how Google won the search engine wars. And then we also calculate the average distance from expertise in the expertise graph. And here are the results. This is what it looks like. We see large cluster of collaborating employees without any direct access to expertise on the periphery. So the large nodes are the experts. The edges are connecting people with a collaboration relationship. And then we have in pink and red the managers, it's 2 tiers, and black are the employees. And from this single picture, and of course the data underlying it that we provide in the process of making this visualization, gives the firm a lot of interesting things. You can see, you can tell a lot of interesting stories from just this picture. Second case study, a guy who's in the news. I made this slide a year ago. I thought it would be a throwaway slide, but he's stuck with us, I guess. So for better or for worse, Twitter has become a major platform for politics. Scraping tweets from the service, from the API, we see how followers of different parties talk with each other around election time. This is a social scientific question, and you can answer a lot of hypotheses in interesting ways doing this. And networks show us the big picture. For example, do people on the left and right ever talk with each other directly anymore? And the specific case is Denmark in 2015. There are 10 major parties, conveniently 5 on the left, 5 on the right. There are about 100,000 accounts that follow these parties. And we took over 5 million tweets from just before the campaign, during the campaign, and for a little while after the government was formed. We analyzed all the tweets using a library called Afin, also in Python. And here's the most negative tweet during the campaign. Once Danish politics was a battle between evil and stupid. Now it's the evil and stupid against some other evil and stupid. And the hashtag stemblankt, I believe, means blank ballot. So this guy's going to vote for none of the above. And here's a quick visualization of the network. So what's the network here? You could say there's a following network, but this is a visualization of who tweets at whom. And we see that there is a big clump of people on the top who follow only parties on the left. There's a smaller, sparser, similar group on the bottom of people who only follow parties on the right. Most people are in the center following some of both parties. But we see that on the ends, there's a high amount of kind of segregation. Although there are a few brave conservatives or perhaps trolls bothering the guys on the left and the top. This is what the average sentiment looks like over time. We split it into 3 groups. The first dotted line is when the incumbent prime minister called new elections. The second dotted line is the date of the elections. And can anyone guess who won the election from the sentiment of their tweets? Was it the left, center, or right? Or let me just say left or right? Sorry? Anyone? Anyway, the right won. You see they, during the campaign, they became extremely negative. And then as soon as the election was won, they shot up. This is the biggest movement in this thing. And the left and the center, over time, kind of were disappointed with the results. Anyway, this is the kind of row type data I was talking about. This is plotting a time series of average sentiments. But how does the networks change? How does the structure of communication in this online world change? Well, using the triadic census function in network X, we see these emergent motifs. During the campaign, we have these first 2 motifs with a lot less back and forth, a lot less reciprocation, and kind of these one-off things that you can imagine are people saying bad things about each other. And underrepresented during the campaign are exactly the motifs where you have a conversation and dialogue between people. And indeed, we see that the average sentiment during in the 3 periods of tweets from a left account to a right account, and from a right account to a left account, there's a dip. There's a significant dip. And under the hood here is a lot of statistics and doing this the rigorous way. But I can assure you that this is an observable phenomenon where the ingredients are simple individuals tweeting at each other, and there's an emergence of real structure that's interesting to analyze. So the last study I wanted to talk about today was corruption in public contracting. So public contracting makes up upwards of 25% of GDP in European EU countries. And this is a major avenue for corruption. If you believe that corruption is a problem in politics, this is one of the largest channels of money from the public purse into private hands. And so clearly there's a lot of risk here. My colleagues and I, we've developed a corruption risk index. And this is a contract level score that all it does is tracks the presence of red flags on individual contracts. So again, this is contract level. Basically, the way public contracting should work is that a public hospital wants to buy beds. They want to buy 100 new beds. They should invite bids from firms to deliver these beds, and then they award the contract to the lowest price offer. Unfortunately, this doesn't happen in practice, and there are many ways to rig the process to guide the contract to your friends at a higher price. And the CRI tracks exactly this phenomenon. And some examples of components that we've collected for all contracts include is there a short bidding time? So basically, if you're the person issuing the contract, you tell your friend's firm ahead of time, and they have a lot of time to prepare, and then you give everybody else just a few days. Another example is the presence of dummy bids. So if you've already rigged the contract and you want to avoid the scrutiny of the regulator, you create fake companies that bid on your contract, and we can detect these. Finally, another example is overdetermination of requirements. So to deliver these hospital beds, or to win this hospital bed contract, you had to have delivered us hospital beds in the past. This is something that happens. Now the question is, how is CRI distributed in the market of issuers and firms? How do we represent this as a market? Well, we can represent as a network. We can represent each market as a bipartite network of winners and issuers. And they're connected by an edge if there's a contracting relationship. And network X.bipartite is a whole module of functions tailored specifically for bipartite graphs. They're very nuanced, and they have their own algorithms and best practices. So you need to be very careful, but network X does a lot of the work for you. And again, we ask the question, do patterns emerge? Here is the most of the Hungarian consulting services market in 2009. So the nodes are firms and issuers, and the edges connect them if they have a contracting relationship in this period. And to make it very simple, the darker red, the more suspicious the contracts are. We see the Hungarian Post was involved in something suspicious. It turns out in 2009 they had an outsourcing program where they basically took the centralized post offices in the medium-sized cities in Hungary and outsourced a lot of the delivery work and work with the villages surrounding them to companies. And this was basically a huge handout to corrupt interests. They also bought bicycles for all of for many of their delivery people, and the average cost of a bicycle was about 1,000 euros. And I can promise you that these are not nice bicycles. These are not fancy top-of-the-line bikes, but nevertheless they cost 1,000 euros a piece. So you also see the Budapest city government making an appearance here, which for Hungarians, I don't know if there are any in the audience, is probably not a big surprise. One thing I found funny was one of the firms winning a contract, a consulting services contract, from an arm of the Budapest city government was a local Tai Chi association. Anyway, make of that what you will. To conclude, there are some alternatives to Network X. So I've done all the work in those 3 case studies entirely in Network X. But if you need some more power, if you have larger networks, if you know anything, if you have some computer science background and you know how the complexity of some of these graph algorithms, you know that as soon as you have bigger networks, you need very powerful tools, and very quickly you need approximation, and you run into intractable problems. There are 2 great alternatives that you can access via Python. The first is iGraph, but the absolute fastest is GraphTool. And I highly recommend you look at these 2 and Network X. And actually, that's all I wanted to say. So thanks a lot.
So let's now proceed with questions. I think the first one is a bit provocative. Is the CRI algorithm open source? I think Slovakia could use it.
That's great. Actually, the CRI is in it's basically the product of a PhD thesis of my colleague Mihai Fazekas. He's a postdoc in Cambridge right now, and actually he started in Hungary, but we have data from 2009 to 2012 for Hungary, Slovakia, and Czech Republic. I actually debated coming up with a Slovakian case, but I felt it was maybe too political. But I think a very famous example a few years ago was the so-called notice board scandal. It's something like there was a huge contract for some kind of thing, and they posted the call for bids in a ministry behind a locked door for a couple of days. And of course, one firm bid and won the big prize. The point is, this data with the CRI is available at digiwist.eu. It's Horizon 2020, so EU-funded project for open data in the European Union on the government side, on the public sector, and we have this data set on Hungary, Slovakia, Czech Republic available for download. So please go have a look at that. And the other work that DigiWist does. They do great work. Digiwist.eu, so short for digital whistleblower. And if you can't find it or you have any specific questions, please find me at lunch or in the next couple hours.
Okay, next one. Can you suggest a non-commercial, production-ready, and having good Python lib to work with graph database, not Neo4j? Cheers.
No, sorry. I've only used Neo4j a few times, and I'm not an expert in graph databases, so sorry.
Does NetworkX allow me to create network infrastructure map easily, example in combination with Nmap?
Sorry, sorry to disappoint again, but I'm not familiar with Nmap. But I think NetworkX is extremely flexible, and so I would be surprised that if there was some incompatibility. But whoever asked, please, we can go through it together. We can figure it out.
Okay, next one. Can you compare bulb flow and NetworkX?
Sorry again, I do not know. I'm not familiar with bulb flow, so sorry. Again, at lunch, please reach out to me.
You are pretty fast with the questions. What do you think about iGraph library? Why do you prefer NetworkX?
That's a good question. I think I have the guy who sits next to me. He is diehard iGraph. He likes it much better. He calls me an idiot for using NetworkX every day, and he's right that it's faster and it has some more powers. But I think NetworkX for me is easier. It's easier to prototype things. You click on the source code, and it's written in pure Python, and you can. For me, it's much easier to modify the algorithms, which in practice. You wind up doing a lot. I'm sure an iGraph expert would say, no, iGraph is also very easy to tweak, but for me, I just learned how to do it in NetworkX, and it's very intuitive for me. To give a very quick example, imagine you have a graph algorithm, a very complicated graph algorithm that isn't implemented for weighted graphs, so graphs with weights on the edges. You have the Python implementation you have the NetworkX implementation of the algorithm for unweighted graphs. Probably it'll be very easy to take a copy of it, to modify it, tweak it a bit, and have what you need up and running quickly.
That was the last question.
No.
Something broke. Yeah, I have to shout. So, thank you for your talk.
Thank you.
And now the time for the lunch break. Hello again after lunch. So first of all, an announcement regarding the lightning talks. There's a whiteboard outside, and if you want to do a lightning talk today, then please go to the whiteboard and write the title and name of you on it. And now we will proceed to the talk. Almost. Well, Petra, are you ready?
Of course.
You're ready. Okay. So our speaker is Petra Cross. Petra is a senior software developer at Google. She worked 11 years for Google. She worked on search, Gmail frontend, and her current project is Android Pay. So welcome on stage, Petra Cross.
Thank you. Thanks for having me. All right. Let me figure out how to work this. Okay. So believe it or not, I do have a cheat sheet for this first slide because I have to tell you a lot about it. First of all, let me thank you, the organizers, Daniele, Richard, and Johnny for having me here. This is the very first PyCon SK in Slovakia, which is my homeland, so it means a lot to me. Thank you. I'm honored to be here. Second, he already introduced me. My name is Petra Cross. I'm a Slovak native. Ja hovorím úplne normálne plynulo po slovensky. Unfortunately, I'm required to speak English today, so we can speak Slovak outside if you want to talk to me in Slovak. This is my email address here, Petka. Please email me your constructive feedback, any kind of suggestions on how to improve this talk. I'd like to do it better next time I do it. Also, if you take any pictures of me, send them to me, okay? Yes, I'm a software engineer at Google. I happen to be the first software engineer at Google from the former Czechoslovakia. So, yay for Slovakia. Yay for women. And in fact, the thing I'm holding there is our 10-year anniversary thank you plaque I received last year. It's going to be 11 years this April. What else? Yes, I worked at 3 different teams. Actually, I worked at multiple, actually a few more, but I cannot talk about them because they were secret. And lastly, in the spirit of Slovak hospitality, I brought gifts. All the Slovak people know that you never show up empty-handed, so I did bring about 6 different products with Google logo on them. So obviously, we don't have enough for everyone. I will make you work for it. 6 of you will receive something, and maybe someone also gets the bag that it came in. All right, and before I go to the next slide, if you hear a child crying, it's because my 10-year-old nugget is outside, so please forgive her. 10-month-old, okay. 10-month-old. All right, what is this? Who knows what this is? You're going to get a prize if you know what this is. Yell. Not the picture. What is the text? No, mission statement. That's the word I was looking for. Come here. Why am I showing you Google's mission statement? Well, everything we do for a reason, right? We're trying to achieve something. So it's kind of nice to remind yourself what is it that Google wants to achieve. We are trying to organize all your information and make it accessible and useful. So pick what you like. There's t-shirts, there's a bag, there is 3 types of vessels for liquids. T-shirt?
Yeah.
What size? There's a large and there's a... Okay, I don't know what this is. Maybe an L. Okay, you're welcome. Yes, it's our mission statement, and everyone at Google actually knows this. And this picture I took from my office. Believe it or not, that's my view. I live in a postcard. I work in a postcard. So what am I here to talk about? I'm going to tell you about 3 different things. I'm going to spend the first part of my talk giving you, because you're all geeks and engineers, this is going to be a little more technical. I'm going to give you the overview of our developer environment. I'm going to tell you what tools we use, what languages we use, how we compile our code. I'm going to show you some pictures of the work environment, the actual offices that we work at. And then I'm going to move to briefly describing the different development workflows used in the industry, not only in software, but also in hardware. And so that I can actually, so that you will see how we arrived at the last one, which we hope is the most advanced one, and it's the one that we use at Google. I wish I had this clicker thing. I don't have a clicker thing. I have to do it manually here. Okay, so the first thing is the Google development environment. And this is another opportunity to receive another Google piece of swag. What kind of swag would you like? Who knows how big is Google? Who knows how big Google is? How many engineers? Okay, not how many employees, how many engineers we have as of last year? 60? We're talking about software engineers, not all employees. More than 15,000? More than 20? I heard some female voice over there, 25,000. Yes, come get something. We don't have female shirt. I apologize. We usually do, but didn't get any today, so we probably can pick some of the other things. We do have 25,000 engineers. When I joined in 2005, there were 2,500 total employees, so maybe 1,000 engineers. Now, what, 10 years later, we have 25,000 engineers plus at least as many people that work in non-engineering departments and then tons of contractors. Yeah, I'll just put it here for everyone to admire. Shopping bag. This is a farmer's market. Enjoy. All right, another opportunity to get another present. How many change lists or submits, how many chunks of codes do we check into our code repository in a single day? Not on a weekend, but on a weekday. 50, less than 20? More than 10,000? 15, someone said 15 over there. Come down, get something. Okay, we still have a few more left. Okay, so 15,000 of them are human, and 30,000 are robotic. So yeah, 35 million per year, and it's going up. And lastly, how big is our code base? How many lines of code do you think Google has? Both human and robotic generated lines of code. Who said 2 billion? Come down. Yes, 2 billion lines of code, and in any given workday, 800,000 compilations, and these compilations generate 2 petabytes worth of data in a single day. All right, enough of statistics. You're welcome. Enjoy. Now I'm going to tell you more. This is more for the geeks here. What is the developer environment like? We have our own Linux distribution. It's called Ubuntu. It's a version of Ubuntu with extra security features and whatnot. You can Google it. There's a Wikipedia article about it, apparently. But before I go into that, all change lists or submits or commits are peer-reviewed. So 2 people see or read, we do have some blind coworkers, all code that goes into code repository. And almost all projects are stored in a single ginormous shared repository that we all have access to. So for example, I have access to any non-secret project within Google. And when I mean non-secret, I mean within Google, non-secret. We develop at head, and we have continuous integration. So that basically ensures that anything that gets checked in passes tests before it gets submitted, so we don't break our coworkers. And there are a few buzzwords here. Server side, we mainly develop in C++, Java, Python, and Go. There are teams that use other languages, but these are the main ones. Obviously, the client side, it depends on what kind of client it is. The iOS would be Objective-C, and then Android would be Java, and the web would be JavaScript, HTML, CSS. People are allowed to use any editor they like. The most popular one is Eclipse. I use Eclipse. There are teams that use IntelliJ. We usually use Emacs or VI for small text file edits. Anything that's not Java, we usually edit in Emacs. And this is the most interesting part of this slide. Most of the infrastructure that we use to develop and build our code is developed internally. We have our own build system called Blaze, which was partially open sourced as Bazel. You can also Google that. We use our own build language, which is following Python syntax. Blaze, by the way, is fully implemented in Python. We use our own bug tracking system called Buganizer. We have used Perforce for code repository. We switched to Piper, which uses SITC as the kind of like a backend server that allows us. SITC means clients in the cloud, or changes in the cloud. I think clients in the cloud. And it allows us to view our pending or old existing submitted changes either in the browser or in our client on the workstation. And it makes it appear on the client as if it was a local file system. It's like a virtual local file system. So I have access to all of the Google code base from my file system as if it was locally stored on my computer. The last few things I wanted to mention is Code Search is a super, super useful tool. That's the tool that I use to search for other examples of the code. Anytime I try to figure out how certain things are done, or I want to see if someone else has done it and I can reuse it, I go into Code Search and I'm searching for buzzwords and keywords to see if there's other code that does similar things to my code, so I can inspire myself, copy and paste, or borrow, or see how other people implemented the same problem that I'm working on. Mondrian and Critique are two code reviewing tools. Like I mentioned at the top of the list, all changes are peer reviewed. So whenever I create a change list, I create a list of files that I'm removing, editing, branching, or adding. I send it to someone else. And that person uses now Critique, previously Mondrian, to view them in like a diff environment. It's a web app. It has like left and right side. You can see the code before the change, code after the change. You can start typing inside of the lines to suggest to the other person, the author of the CL, change list, what to change. It's a really nice tool to communicate the process of a code review. Mondrian was, by the way, the first large project developed by Guido van Rossum, who is, as all you know, hopefully the Python creator. Mondrian was fully implemented in Python. I'm not sure if Critique is. So you can probably search for any of these. They were publicly at some point announced. And now I'm going to talk about how we organize within our floor at Google, how our team's structured, who reports to whom, and why it's good and why it works for us. So here's a typical structure. You obviously have a VP of engineering there. VP of engineering, she might report to SVP, Senior VP of Engineering, and that person might report to CEO, for example. But a typical VP of engineering would be managing multiple engineering directors. An engineering director would then be managing multiple engineering managers, and each manager manages anywhere between 4 to 30 people. And what's the point of this slide is, notice how flat this last level is. It's clear that we're trying to keep the engineering structure quite flat. We are not trying to put too many levels of managers. At some point, I was like 4 levels away from Larry Page in terms of reporting structure. So you can imagine how big the company is and how flat it is at the very bottom. So this does look like it's a really big team. How can they all work together? Well, you can think of this like this can be, let's say, Gmail team. It'll be way more people than that, right? But each of these groups of people belonging to a different sub-team, depending on what project needs to be done right now. So it does look like this is a single team, and we are a single team. We would go to the same offsite together. But on a day-to-day basis, we work in groups. So this is like a typical division. You would have anywhere between 4 to 7 people in a team, in a sub-team. Those are the people that you work with every single day. Every team has to have one tech lead, TL. Tech lead is one of the software engineers that is demonstrating leadership skills and is good at organizing the work for the team and can represent the team in meetings and so forth. and works with the manager and the VP on the planning and launches and things like that. Some software engineers might be managing an intern for the summer. Some software engineers that are tech leads might be promoted to managers. TLM means tech lead manager. A tech lead manager is just like any other tech lead, but they also have to have additional manager duties. I don't think I'm going to go into this slide. This is basically a description of all those three-letter acronyms from the previous slide, but I think it was clear from that. And I'm going to end with some pictures here. This section of my talk was about showing you the work environment and the software environment that we work in. This is a picture circa 2008 Gmail. Around the time when Gmail just went out of beta, Gmail was 5 years old. We, as you can see, worked in a really dark, small room. But the point here is to show you that people sit next to each other, they hear each other. It works. You don't need to have your own office. I'm sure many of you work in similar situations where you have people near you. It enhances collaboration between people. This is my dog. She's not here anymore, but she used to go to work. And this is the little larger room that we moved to circa 2011, 2012. Again, clusters of desks. And let's say this floor that you can see here, it maybe contains people from two teams, two sub-teams. And there's offices. Some offices might have 4 or 5 people in them. That's another team in the office. And on the other side of the wall, there might be another team with like 4 to 6 people. What's worth pointing out in this picture here, on the right side, do you see this green thing, the monitor with green thing on it? Upper right? Do you see it? Yes, no? Yes. You can see lines of color. Most of them are green, but 2 of them are red. Those are continuous builds that I was telling you about. We define which part of code base gets continuously built and tested. From a small section, the smoke test, we can have a build called smoke test. We can have build that builds completely everything, the world. We call it the world. Or it can be a build that only runs integration tests, which are flaky and they run every 30 minutes or something. And you want to separate them into separate builds so it doesn't slow down the other builds. So depending on the team's needs, they might create 1 or more continuous builds. They configure them. And we can see their status right there on the screen. So anytime I want to sync to head, if everything's green, I know I'm good. I can sync. Nothing's broken. All right, last few pictures. This is, again, a view from my desk. I love taking pictures because it changes every single day. It's pretty amazing. Some of them are taken in a single day. All right. Huh?
There should be fog. There's always fog.
Oh, here's a fog. Clouds. Well, when there is fog, you cannot see the bridge, so I wouldn't be able to show you the picture. So these offices are nice, but what is it that we're trying to do inside? No? No one was paying attention earlier in the talk? Who said organizing? Come down, get one of these things. We have, I think, 2 things left here. Yes, we're trying to organize world information, make it universally accessible and useful. Okay, let's move into the second section of my talk. I'm going to talk about, enjoy. I'm going to talk about the different ways companies develop products or software. This is just really a high level. It's more like a walk down the history lane. It's more like a background on how things used to be done. And then I'm going to talk about what we do at Google. So anytime you need to create anything, you start with an idea, right? A given feature starts with an idea. Then you tell someone about your idea, right? Your PM or your manager or someone. And a group of people decides that it's time to do it, so it's being planned. It's in some list waiting for the time when it's a good time to start implementing it. So it spends a few days or weeks in some kind of queue. It's being planned. And then it spends another chunk of time, anywhere between days and months, maybe even years, being worked on. People are working on this. When it's done, it goes into the code review. When it's code reviewed, checked in, Then maybe QA team is testing it in case of a mobile application. Maybe the QA team needs to get that Android build that contains your change and test all the functionality, make sure it works. And then it goes into canary. By the way, the word canary, I spent 10 years saying it wrong. I used to say canary. And you know what canary and canary, what the difference is? Canary is conservare. That's where you make cans. And canary is the staging environment which you use to release code to production. So now I know how to say it. Once it's in canary for some time, canary for some time. Like I said, I always do it wrong. Then it goes live. You start with 5%, 1%, and then slowly ramp it up to 100% of users. So all of this takes a lot of time, from the moment someone thinks of the idea to the moment when it's live and public. And what we're trying to do is, we're trying to shrink this total length it takes, total time it takes to make all of this, right? We don't want to spend years to develop a single feature. So we want to do this fast, and therefore we need to only do what needs to be done, so we don't spend our spare cycles on things that are unnecessary. And as far as the company cares, they want to maximize return on investment on developer time. So how do you speed up your development? You can either add resources, or as we call it, throw money at it, or throw people at it, or you can reduce waste. So what do you think we should be doing? You got the last prize. Yes, reduce waste. And I'm going to tell you basically how we do that. I'm going to just fly through this one. We are not trying to waste money. There are some examples, or some people believe, here's the source, that between 60 billion and 70 billion, that's billion is miliarda in Slovak, right? Of US dollars are wasted every single year. And there is a list of some failed products you can look at. My homeland now, state of California, wasted how much? $44 million on a DMV system, Department of Motor Vehicles, implemented something which they never used and wasted $44 million. So we're trying to avoid this. Okay, so how do companies develop software? There are really most common, three of them are most common methodologies. The old school waterfall, the spiral, and the agile. Have you heard of waterfall? Some of you, who heard of spiral? And who heard of agile? Okay, good. So apparently, waterfall is the predecessor of a spiral, and spiral is the predecessor of agile. So this is the grandma, mommy, and that's the child. Let me tell you about waterfall. What's a waterfall? It comes from manufacturing and construction industries. So imagine you're trying to construct a building. Before you start building it, you need to know the requirements. The design needs to be done. And then you can build it. And then someone comes in and does, fire department check and whatnot, verifies that the building's functional. And then it can be used and maintained. This entire thing might take years. It wouldn't take months, it would take years. We obviously cannot use this methodology in software because you don't know what users want. You cannot predict what requirements you will have a month from now, 2 months from now, a year from now. But it's good to know what the waterfall is or what it was. So the first software companies tried to adapt waterfall to their needs, and what they did, they invented this thing called a spiral methodology, which basically is a waterfall, but many times in a row. Like small waterfalls, one after another. At the end of each waterfall, you don't end up with a finished product, but you end up with a prototype. So each spiral goes through the same stages that the waterfall would go through, but ends in a prototype. So it's zero-based. So you start prototype 0, prototype 1, prototype 2, and the entire cycle takes about 6 months in average. Well, that's much better than doing it all at once and 5 years down the road coming up with a product no one wants, but it's still pretty slow that you have a prototype in 6 months. So imagine it's like if you were driving a boat. Imagine you're driving a boat, and you're not allowed to steer the wheel like this, but you're only allowed to steer the wheel once an hour. Right? You will go like zigzag. You're not going to go straight. You're wasting a lot of energy if you're not focused. So this doesn't really work well, at least for us. And here comes Agile. So Agile is basically a modified spiral, which is constantly spinning in a very short cycles that are not 6 months long, but more like a week or week and a half or 2 weeks long. I'm sure all of you have your own definition of what Agile is. I'm not going to argue with anyone because we can get into heated discussions here. This is how I define it. Customer collaboration is number one. You need to know your customers. In our case, in my current team, our product manager knows our customers. So product manager is really my customer. And I get constant feedback from product manager. I talk to them every single day. I don't get requirements up front and then work for 6 months. I keep coming to product manager every day or every other day and clarifying things or suggesting slight modifications to the original requirements based on engineering constraints. So this allows us to respond to change really quickly and not spend weeks or months doing something that at the end no one's going to want or use. We iterate based on features, we are not creating prototypes, we are creating features. So each feature has a set of tasks and we are working on them in a given iteration. We release early and often and we get feedback from customers. When I say early and often, I check in my code and the next continuous build might pick it up in 40 minutes. 2 hours later, my code is released in some staging in sandbox environment. So for example, I can use it on my phone. Obviously, it's not going to production. No one's going to use it outside of Google, but I get to use this. We used to do this with Gmail, and it was driving me crazy. When I was on Gmail team, if someone broke the build or checked in a bad feature, no one could use their email because we call it dog fooding. That's called actually fish fooding. We were fish fooding our own code, and when we broke something, everyone on our team was pissed at us. So that's a really good motivator to not break things. Where am I? Self-organization. Teams form based on the current project needs. The team that I'm on, it's never set in stone. 2 months later, I might be in a different team. The manager will be just like moving people from one team to another depending on where we need more help. Open office to speed collaboration. I already have shown you some pictures of our offices. And frequent introspection. I will talk about retrospectives almost at the end of the talk. There are a few more words that you must have heard in conjunction to the word agile. And again, everyone defines them differently. This is how I define them. Extreme programming, Scrum, and Kanban. Extreme programming is known for a so-called promiscuous pairing. You are promiscuous in terms of who you are coding with, and every day you might code with someone else. That's why there's the double chair. One day you might be coding with a coworker, another day you're going to code with someone over the Google Hangout, or you basically never know who you're going to work next day. It all depends who is free and who needs help. Scrum is a project management methodology, so I don't know anything about it. Don't ask me about Scrum, but I know that it's not something we use. Project managers use it. And Kanban is an idea that came from just-in-time manufacturing from Japan. I was told that Kanban means whiteboard or card or something like that. Do we have a Japanese person here? No? So it's supposed to be some kind of card or tablet or something. And here's a picture of a Kanban card from, what is this? Is this like a Toyota or something? Toyota Altona car. A Kanban card contains the information that's attached to a physical object, in this case, in car manufacturing. And it tells you what this thing is, where it has been just now, and where it's going next. All you need to know is, what is this thing, and what am I supposed to do with it now? And that's what Kanban card contains. It doesn't talk about anything that's like 5 steps down the line. It only talks about the previous and the very next step, or only the next step. And we're gonna borrow the idea of Kanban in the next slides. That's why I'm showing it to you. So we're going to the last and actually the largest part of my talk. I'm going to talk about how we at Google do Agile. So what does Google do? A little bit of everything. We call it Agile. We don't have special words for it. And you know how I was showing you the Google mission statement? There's another thing that we keep reminding ourselves of. It's called 10 things we find to be true. You can just Google it. It's just search for 10 things. It should be like first or second result. It's a list of things that are the truths that we believe in. The first one is focus on the users, and everything else will follow. And in that spirit, we do focus on users. We start with user stories. And these come from the PM or from the users themselves. And as engineers, I never think of user stories. I only think of engineering tasks. There is a big difference between user stories and engineering tasks. This is one of the biggest problems that I see when I see how other companies often do Agile. They don't differentiate between user story and engineering task. A user story example would be you want to build ATM. That's in Slovak, that's bankomat. You want to build an ATM. It needs to have some features. So 2 features might be ATM needs to allow users to see their balance. Another feature might be a district bank manager might want to view all the ATM usage in their town. These are user stories. If someone gives that to me, I don't know what to do with it. I'm an engineer. Like, I don't know, right? So product manager and UX team work on these ideas of the user stories, and they come up with specific requirements. They give us mocks, for example, of what the screen should look like and what it should say and how the user types in their credentials and whatnot, right? We receive that as engineers, and we then translate this user story, into engineering tasks. Here's an example. Actually, next slide we'll have an example, but to give you an idea, a task is a single Kanban card from the previous slide, which describes what needs to be done. That thing that needs to be done shouldn't take more than 2 to 12 hours of work. It should never be a task that takes a week. If it takes a week, break it down into smaller tasks. It should be very digestible, very nice, small task that you're not going to be afraid to pick up from a whiteboard or from a spreadsheet. Something you want to work on because you know it's not too small and it's not too big. Actually, there's no such thing as too small. You can have a 1-line change and it might take you 3 hours. Amen. A typical task will have a description. It has to have a size, which I'm going to talk about later. And it needs to have an owner once someone starts working on it. And a state, which is the most important thing. We need to know what's going on with this thing. Is anyone working on it? Is it done? Is it blocked? Is it being tested? Or is it already out in production? So the way we break down the tasks would be for a user story that says a bankomat ATM user needs to view their balance, we might break it down into a task that first needs to define the API between the bank and the client, which is bankomat, right, the ATM, whatever software that thing runs. So someone needs to define the API. So that's the first task. Then someone needs to implement this API on the back end, right, in whatever language of choice they have, hopefully Python. And that will obviously break down into many other more tasks because you need to authenticate the users, you need to deal with load balancing, you have a million other things you need to worry about as a backend engineers, but PM doesn't care. They only care that you're going to allow users to view their balance, right? This is an engineering problem to figure out what needs to be done and to break this down into tasks. PM never gives me tasks, never. They only tell me what they want the user to have, view, or use, right? I'm the one who decides how it gets done, and I define these tasks. So this will be a typical second task. And third task might be a client development, some kind of user interface, some screen that's going to display the balance in the actual ATM. I don't know what that thing runs, some HTTP, some PHP, HTML, CSS, so I don't know, whatever they use, right? Some client developer will take that and break that into multiple tasks for themselves. So again, PM doesn't know anything about engineering tasks. That's our internal problem, how we divide them up. PM only cares about user stories, and that's why it's important to never give user stories to engineers and tell them work on this, because they don't know how. They only know how to work on tasks. They can break them up, down into smaller tasks, but it's not okay to just give someone a story and be like, go implement this, because you don't implement the story, you implement the task. So where do we put these tasks? You can put them, oh, we don't have a gift anyways, okay, into list buckets or swim lanes. So depending on the state, if is it being worked on, or is it done, or is it blocked, or is it being tested, or depending on the state, you put it in some kind of a bucket. And what do these buckets look like? So it depends. If all of you and your coworkers are in the same room, and you don't work in a distributed work environment, you can just have a simple whiteboard where you're going to put this thing called swim lanes. You know how at the bottom of a swimming pool you have these lines, swim lanes? So each of these is a swim lane, and each swim lane contains tasks that have the same state. On the left, for example, you have scheduled, which I believe is backlog. This big swim lane right here is working on, which means pending, working on, being developed. This thing means checked in. I don't know why they have that swim lane. You figure out which swim lanes you need. It's not something that you know before you start working as a team. Sometimes you need to add more swim lanes, and that's fine. And then here they have in QA, and there's one more on the right, which I don't know what that is. Maybe done or verified or tested or something. Or you can use, instead of a whiteboard, if you want to keep everything in a spreadsheet, and for example, if you want to be able to work from home and have access to this, instead of pointing a camera at the whiteboard and doing a live stream, you can just put everything in a spreadsheet. So this is another example of how you can put the same information in a spreadsheet. So it's up to you how you visualize it. You can use any tool available out there. There are few that I recommend. Whiteboard is the easiest one. There's something special about being able to hold that card in your hand, something tangible about it that makes you feel like, okay, this is a thing I need to do. I'm holding in my hands. I'm not going to throw it away. It's a task. I have to do it. You don't have that feeling when you're looking at a spreadsheet, but spreadsheet works just fine. You can use your favorite tracking software, Pivotal Tracker, or the ever-popular Asana for your task tracking. So now that I told you where we put these things, I'm going to talk about these logical buckets based on the state. And now I have to drink. All right. So before you start working on something, it's just an idea, right? It might not even be a task. It might just be a user story. You didn't bother breaking it down into a task. It's still just a user story. It's something that your PM told you, and you're like, yeah, sure, one day we'll do it. Yeah, right. And you know you'll never do it, okay? Or you might do it one day. So what do you do with this stuff that people ask you to do, right? You put it on ice so it doesn't get spoiled. That's why it's called ice box. It's a box full of ice where you can put meat and it stays fresh. You put tasks in it that might get done one day or never. There's no commitment. You don't feel bad about having a million things in ice box. It's just an ice box. It's fine. It's frozen. Nothing's going to happen to it. The next bucket that you have is the one that you use most often. It's called backlog, or scheduled, or to be worked on next. Backlog, I will have a separate slide about it. I think we all know what backlog is. It just means something that you need to do in the next week or two. Then you have the one that shows you what is being worked on, current, or working on, or in progress. You can call it whatever you want. And once it's done, it goes into the done bucket. Now, like you saw in those swim lanes in the picture, some people add more buckets. If you have a big QA team and you need to QA everything, then you might have a bucket called in QA or something like that. So it's up to you what your company needs. So let's talk about Icebox. In my specific implementation, this is how I would implement an Icebox in a spreadsheet. You can put it on the back of the whiteboard. When I used whiteboards, I used to put every single request that came my way when I was a tech lead, every request that other teams gave me, or my manager gave me, or the PMs gave me, I would write down on a card as a user story, and I would just slap it on the back of a whiteboard so no one can see it. It's not like I'm going to look at it every day and feel bad that I haven't done it, right? So when our team became more distributed and some people were working from home and we started using a spreadsheet, this is actually a Google spreadsheet, works really well for sharing. I just created a separate tab for it. It's a tab at the bottom of a spreadsheet. So we have two tabs. This is the second tab. And here's an example. You can put both user stories, features, or tasks into it. It doesn't matter. You don't need to break it down into tasks, but you can. It's up to you. Someone asked me for to do something, and I just put it right here. Or someone reports a bug, I just put it right there. I can put a link to the bugonizer so I can see the details, or some stack trace or something that's related to the bug. But as a task or as a user story, it lives here until we decide that it's time to start working on it. All right, so that's Icebox. That's pretty straightforward. Here I'm saying that I'm showing you that a single feature might be broken down into tasks, but doesn't need to be. Like these guys aren't broken down into tasks. They probably never get done anyways. So every request starts in Icebox, unless you have like a production emergency and you need to fix something right away. You're not going to put it in Icebox, but everything else goes into Icebox first. It's a dumping ground for all the requests and bugs. And it may never get done, and probably will never get done. Maybe 90% of it, maybe 80%. So that's Icebox. Backlog. So what I've done, I created a sheet within a spreadsheet, a tab, that contains multiple states. So this is both backlog, in progress, and done. You don't need to have separate spreadsheet for every single state. Sometimes it makes sense to have it all in one place. What this spreadsheet contains is everything that is being done this iteration. And this is what every team member looks at every single day. This is the most important sheet. You don't even need to keep the Icebox fancy. That can be like a pile of papers on someone's desk. But this needs to be organized. This is the thing you need to put most effort into, because this is what runs your team. As you can see, it's split into two sections here. You don't put more than 1 or 1.5 iterations worth of tasks here. So in our case, the iteration was 1 week long. It was from October 7th to October 14th. So that's our current iteration, or it was our current iteration. And I put a few more here for the next iteration, just in case someone gets really fast and like we finish it before the end of the week and we have nothing else to work on. We can start working on this. But the thing about this blue line is what we really care about. That's what we are planning to accomplish in the week. As you can see, every single feature is broken down into tasks. Like notice feature A is there twice. And it's because we think that it's important to finish the task 1 and task 2 from user story B before we continue working on user story A. So you can actually break up user stories and prioritize within, the task within them. You don't need to finish the entire user story all at once. Let me show you what is the backlog. In this case, oh yeah, it must be ordered by priority. That's very important. The thing on top has to be done first, no matter how fun or boring the task is. You never pre-assign owners. Even if there's someone who has done it a million times, you never ask anyone to do it, because everyone on the team needs to learn how to do it. And if I have never done it, and I happen to be free now, I'm going to take that task. And if I don't know how, I will talk to the person who has done it last time. It will take me a little longer first time I do it, But if I do it 2 or 3 times, a similar kind of thing, I'll know how to do it. And now we have 2 experts on the team. You don't want to create these silos where someone gets hit by a bus and no one knows how to do this thing. This is very important. People are nodding here, okay. Someone agrees. Okay. So do not pre-assign owners. And don't put more than 1 or 1.5 amount of worth of iterations. Don't put too many tasks there, because you don't know what's going to happen next week. Maybe by the end of this week, you don't even want to work on this. So why did you waste your time planning this for 5 weeks ahead when this can change anytime? We want to be agile. Remember, we don't plan for many, many weeks. We only plan for 1 iteration. Am I speaking too fast? I usually do. Huh? Am I what? I'm agile. Okay. So yeah, this is very important. You always pick the highest priority task that is not already taken. Current. This is just how you mark what is being worked on. And when you work on something, you put your name there so people can tell what you're doing. In this case, Maria and Alex are both working on tasks. I am idle, obviously, because I just finished the first task. So that means I need to pick the next task. Which task should I pick now? Task 3? It says blocked. I need to wait until Maria is done with task 2. Which task should I pick? Yeah, feature beef task 2. That's the one I put my name next to, and I mark it as in progress. All right. So this is our backlog. It's really within the same iteration. We call it iteration spreadsheet because it contains everything we need for a single iteration. It contains backlog, it contains current, working on, and it contains done for this iteration. So working on and done. And this is our bucket for things that were done. At the end of the week, what does this look like? Hopefully, it's all green. So by the end of the iteration, you expect it to be green, and you can actually track it. At the end of the week, you can add up all these points, get a total here, and graph it over time, just to see how, they call it velocity, to see how fast your team can move in terms of points. Those are not days, those are points, and I'll talk about them later. So again, engineers don't care about this tracking because they're just working on tasks, right? But PMs and managers, they always ask you, when are you going to be done? How long is this going to take? So what I tell them, well, give me the user stories. I'm going to break them down into tasks. And I'm going to add up. Then we need to estimate all the tasks. And then I can add up all the points. And if it says 100 points, right? If my team does 10 points per week, I'll tell them it's going to take 10 weeks. And it turns out it's much better way of predicting how long things take than asking someone how long it's going to take them. Because when you ask anyone how long it's going to take them, they think they can do it in 2 weeks. It's going to take them 4 or 6. Everything takes longer than people think, and engineers or anyone cannot predict how long things are going to take. True that. So that's why we think in terms of points, not time. And these points mean how complicated things are, how difficult this task is, not how long it's going to take me. Okay. Pop quiz. Which buckets do we have? The most important 4. And I will give you pens. I only have 3 pens left. Not icebox. Backlog. Current or working on. Done. Okay. There you go. Yes, these are the 4 that you absolutely should have. You call them whatever you want, in whatever language you speak, but it just makes sense. You need to have these 4. And you can add more if you need to. There's some special step or state that your tasks go into. You can add more, but it all depends on the type of the project you work on. So now I'm going to tell you about how do these tasks end up on the whiteboard or in the backlog. How do we put them in the backlog? Who puts them in the backlog? Because I said PM does not think in terms of tasks. PM thinks in terms of user stories. Engineers think in terms of tasks. So who does the translation between the user story and the tasks? Am I speaking too slow now? I don't know. I never know if I'm going too fast or too slow. I try to slow down. So obviously it happens at a meeting. It doesn't need to be in the meeting room. It can be at someone's desk. It doesn't need to involve every team member. You really need only 3 people, 3 or 4 people. The rest of the team doesn't need to be there. Let them have their hours of their life. Like, let them work on something else. You don't need to put the whole team in the same room. But in order to break tasks down into break down user stories into tasks, you need at least 3 people, because one person can never think of all the things that need to be done. You need to define what needs to be done. That's what it is. By breaking tasks, by breaking user stories into tasks, you're really just like going through an exercise in your head of how am I going to implement this? Oh, I need this, I need that. Oh, we need to do this first, and we need to do that first, and oh, it's blocked because that team needs to finish that first. Like, you go through the exercise in your head to realize what needs to be done, and then you realize how much work it is and how long it might take, because you're blocked on that person, blocked on that team, and you have to come up with that workaround. And you understand what I'm saying? Okay. So it happens during a meeting called planning meeting. So pre-planning meeting is when a PM and tech lead meets. So I basically come to the PM and be like, hey, so you want me to do this feature? Okay, how do you like envision that to look like? So I get a product requirements document or some mocks or something. I might have clarifying questions. I'm trying to understand as a tech lead, what is it that we need to implement, that my team needs to implement? Once I understand it, then I am going to break this down into multiple tasks. And then I'm going to share it with 1 or 2 members of my team to quickly read through it to see if it makes sense, if I missed anything. Because they'll be like, oh, you forgot this. You cannot use this form of authentication because that's deprecated. We need to implement this new authenticator, blah, 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 right? There's always something that prevents you from easily finishing your tasks. So you try to identify these blockers at this stage. And this is before I meet with the rest of my team. And now that I'm done with it, a Wednesday comes by. We have, where is it? 1 hour, which really, it should be 30 minutes. It shouldn't be 1 hour. You can do it in 30 minutes. We have a 30-minute meeting, and that's when the magic happens. This is the part that I hope I will be able to convey to you. It has a specific way of conducting this meeting. It's not just like, oh, let's read through these stories and let's see how hard they are. Let's put some points next to them. Let's estimate it. It's not like that. You're not always allowed to talk. You have to follow a certain structure. There is a person that's facilitating the meeting facilitator. It can be the TL or it can be someone else. If you want to empower or grow leaders from within your team, you just ask a different person every week to run this meeting. And this person comes to the meeting, let's say my coworker Alex. And I'll be like, okay, Alex is running this estimation meeting today. So Alex goes into the spreadsheet. And let me go back to the spreadsheet actually. Alex opens the spreadsheet. This entire row is clear. There's no numbers here. And he just reads out task 1, feature 8. He reads it out loud. And we hold these cards, or you can use your fingers. It's much easier with fingers. And he goes, okay, 1, 2, 3. And we vote. So I gave it 2 points. We look around at the table, and we see how many points other people gave. So for example, here, this is what happens. So let's say we have 3 people in the team, and 2 of them say 2, and 1 of them has 5. We're like, okay, so the person who said 5, they either don't realize how easy this task is, or they know something we don't know, right? Because maybe it is a lot more work and we just didn't know. And this is the most important part. we learn from one another what really needs to be done, and it's like part of the understanding of how things get done, allow us to work only on the things that need to get done. Do you know what I mean? If this person picked up the task, the person who said it's 2 points, actually no. Imagine this is a super easy task. It only takes really 2 points. If we didn't estimate this and the third person picked it up who thinks it's too much work, they might do it in like a really bad brute force way, or use the wrong API to do it, or implement an API that already exists, or do something that's unnecessary to do. And because we talk about this at the meeting, we were like, wait a second, this isn't 5 points. Why do you think it's 5 points? And we clarify this. We save this guy or girl a few days worth of work, because they don't have to reinvent the wheel, so to say, but they will do it the easy way that these two people know how to do, right? So this is what the meeting looks like. So I read the task. Define an API for ATM for fetching balances from the ATMs. That's the task. I read it out, or the person reads it out. And I say 1, 2, 3. People lift their hands, or the cards with the numbers. This is what the cards look like. It's a modified Fibonacci scale. And I look around the table. If there are no obviously big outliers or small outliers, we don't even discuss this. I'm just going to write down like an average. I just calculate the mean and write it down. I'll just say 2. And we go to the next task. No discussion needed, because obviously everyone knows how to do it, and they think it's an easy task. If there is an outlier, then we go by pointing at the person with the lowest score, one of the people that said 2, and I say, to do this task. And they say, to do this task, you always have to say, to do this task, one has to do A, B, and C. Okay, then I say, okay, you, the person with 5. And they say, to do this task, one has to do A, B, and C, plus I have to do this, this, and that. We're like, oh, okay, let's revote. 1, 2, 3. I mean, everyone now says 5, because everyone understood this is actually more work. And in our head, we know what it takes to do, and that's part of the magic of estimating. So the estimating, for a product manager, for them, it's useful because that allows the tech lead to kind of give them the timeline, like how long it's going to take, right? But really, we are not estimating it for product manager. We're estimating it so that we know how to do these tasks. And then we don't have to have daily stand-ups and ask people for help all the time, or see someone waste 2 weeks doing something that's completely unnecessary. So the planning poker is a fun thing to use. People like to play with those cards, or just use your fingers. Planning rules. So what happens before this meeting, a tech lead goes behind the whiteboard, picks up those tasks, those user stories or tasks from the icebox, puts them into the backlog, orders them by priority, makes sure the PM is happy with that priority, because PM wants certain things to be done first, right? So PM is happy with the priority things are on the backlog, and then the meeting happens where we estimate the tasks. Then we estimate the tasks, only 1 iteration worth of tasks, and then everyone goes back to their desks and can start programming. And this happens every week. And at the end of the week, we just clear out everything that's done. Put more tasks from the icebox into the backlog. Again, we might reprioritize some of that stuff, make sure that PM is still happy with our priorities, and repeat. So once the week begins, I mean, in our case, the week begins on Wednesday when our estimation meeting ends. That's the beginning of an iteration. So when you're done estimating, the iteration has officially started, and you have 1 week, or some people do 2-week iterations, to complete all the tasks for that given iteration. And during that week, don't pick and choose what you like to do. I'm sure there's some fun tasks, right? But you don't want to be disliked by your coworkers, first of all. you want to be nice to other people, and everyone gets their share of so-called shit work, right? If there's a shitty task, and you happen to be one who is ready to start working on something, and the shitty task is on top, too bad, it's your shitty task. You're going to work on it. Next week, someone else gets the shitty task. I mean, how do they say it? Karma is a bitch, right? Everyone gets shitty tasks at some point. So don't feel like, I mean, statistically, you're not going to end up with all the shitty tasks. You might have 2 or 3 in a row, but you're not going to be doing all of them, so don't worry about it. Yeah, I might be working on 1 or 2, sometimes 3 tasks. The reason why I'm working on multiple tasks is because some of them might be blocked. Or if I'm working on integration tests and they run for 30 minutes, I'm not going to be twiddling my thumbs, right? I mean, there's only so many coffees I can drink in a day. It's not like I'm going to go have coffee every time I turn on the test. So I have 30 minutes to do something else. I pick a task from the whiteboard. So I do 2 things at the same time. It's very common people work on 2 things at the same time. And what's beautiful about the task tracking is that anyone who gets to see the whiteboard knows who is working on what, who is blocked on what, which task is in what state of doneness. And you don't need to be sending any kind of status reports to anyone. Your manager wants to know how you're doing. I'll be like, haven't you seen the backlog? Just look at the backlog, you'll know what we're doing. You don't need to do unnecessary meetings and status meetings and stand-ups. Stand-ups are good for certain situations, but if you are doing this right, you do not need stand-ups. Because think about how much time you waste during a stand-up. Let's say you have, in the best case, 10-minute stand-up every single morning. So that's 5 times a week, so that's 50 minutes. How many people are on the team? Let's say 4 people. 200 minutes of engineering time wasted on stand-ups, when all you needed to do is to look at the whiteboard or backlog and see who is working on what, who is blocked on what, and if someone has a question or needs to get advice from the rest of the team, we all sit in the same room. I can just walk over and be like, hey, I'm doing this thing. You've done it like 3 months ago. How did you do that? Or like, whatever, right? You don't need everyone to be standing around and listening to you having conversation with one person. So I believe stand-ups are unnecessary. Personal opinion. And this is, again, to prove my point, this is what happens to you when you do stand-up. Stand-up comedy. Yes, it is wasted time. If you do stand-up, who doesn't know what stand-up is? All right, so stand-up is a meeting where people are standing because when you stand, you don't want a meeting to last for too long because it's uncomfortable to stand. So because everyone stands, that ensures the meeting is not going to last for too long. And it's like a quick status meeting that happens usually in the morning every single day, where you have 4 to 6 people in a circle, and they usually hold a sponge or a stick or something. There's supposed to be some kind of talking stick, like a totem or some Indian, Native American thing. Or you can just grab a sponge. We don't have a sponge, but like imagine this is a sponge. I'm holding a dirty sponge. I have the right to speak, no one else. So I'll be like, okay, well, yesterday I was mainly blocked on this thing. I had a meeting with so-and-so, and I found out that we cannot really do it this way because blah, 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 blah. I'll give them the status of what I'm working on, right? And today I'm trying to accomplish this. I'm trying to finish this integration test. I'm trying to finish your code review, and I'm sorry, I've been too busy. I'll finish your code review too, and blah, 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 right? This is basically what a stand-up is. And then I'm done talking, I give it to someone else, and this other person grabs the object that gives them the right to talk, and they hold it, and they'll be like, all right, well, I have done this yesterday, and this is what I want to do today. And then it goes like this in circle. When you finish the circle, we all just go back to our desks. 10 minutes wasted, just like that. Okay? So try to avoid stand-ups unless you absolutely have them. Teams that don't do agile, they need to do stand-ups, because how else are they going to communicate what is everyone working on? They need to have stand-ups to communicate the status. Do you do stand-ups? Okay, good. Okay, what time is it? I think I'm going too fast. Okay, 2 minutes. Ah, yes, this is the one to the last slide. Okay. Retrospective. Retrospective is something that if you want to improve what you're doing, you should have retrospective. At the beginning of the talk, I asked you to send me your feedback about this talk. That's my version, my way of doing retrospective. I'm trying to improve what I'm doing. I need to get feedback from you so I can improve my talk. In retrospective, you would do it maybe once a month or once a quarter. You get people in the room for 1 hour. You give everyone 3 post-it notes, 3 sticky notes, like this. You can color coordinate, or it can just be white, doesn't matter. Oh wow, these guys have 4. Okay, so here's a smiley face. So you go on a whiteboard, you have a whiteboard, you make a big cross on it. You divide it into 4 quadrants. You put a smiley face in one quadrant, this one. You put a sad face in the other quadrant. Look, it's even covered with stickers. That's how unhappy these people are. Then you put what is it? The light bulb for ideas and suggestions, right? And I don't know what the 4th one is. I think those are action items or something. And everyone has 5 minutes to write what they want on those 3 stickers. On the first sticker, they're going to say what went well, what they're happy with. They love the offsite. They love that people now do code reviews fast and you have to wait for them. They love blah, blah, blah. Whatever they like, they describe. On the other sticker, they say what they don't like, things that don't go well. You can complain, the build is always broken. It takes me forever to sync to a good CL change list or sync to head. You can complain about anything you want. Mainly process things that can be possibly improved by changing the process and the way you work as a team. And in the 3rd one, in the last card, you're going to write your ideas and suggestions. Because it's really easy to complain, right? But do you have a solution? Sure. Write it on a little post-it note. And then when everyone's done writing in 5 minutes, we go in circles and we read all the happy cards first. We write them, or we just stick them here and read them out loud. And then we brainstorm the ideas of what do we want to do to improve the situation so we don't end up with any unhappy faces next month or next quarter. And at the end, you always go home from the meeting, you go away from the meeting with action items that have owners. Because it's one thing to say, oh, it would be so cool if we have an offsite, let's go on a trip. But there's no one to plan it, it's not going to happen, right? So always assign the things that people agree on as action items. Make sure they have owners. And they can be tasks, and they can go back on the whiteboard, on the backlog. So I promised, right before Q&A, this is the last thing I want you to remember. There's a lot here, but if you don't remember anything else from this talk, these are the main things I want you to remember. There's a difference between feature or user story and a task. Always break them down and always differentiate the two. Always estimate the complexity of the task, not the time it takes to make the task. Because you never will be able to estimate the time. You will always be wrong by the factor of 2 at least. Estimating is not about writing down numbers. It's about clarifying what needs to be done. Because that process of estimating is what matters, not those numbers, but the process of going through the exercise. Always order tasks on the whiteboard by priority, and always work from the top. Have everyone work from the same list of tasks, top to bottom, estimate and repeat every 1 to 2 weeks, and look back once a month during retrospectives. And this is the last, this is a Q&A that you were asking me to start. We can start with Q&A. And don't forget to send me an email if you have any questions, petka@google.com.
Okay, we have plenty of questions. I probably won't be able to answer all of them. So first one, do people leave your open space to find a quiet place to actually get some work done?
You get most of the work done, believe it or not, at your desk. You only need quiet place when you need to conduct a phone screen, an interview, or when you need to have some private meeting. For that, we have conference rooms, all sizes from large rooms like this to small huddle rooms for 1 or 2 person. It's not very loud on the floor. Sometimes you hear laughs, but and sometimes people use the F word when they get pissed off, but you don't really hear much other than that. So it's not like it's not very loud, it's not very disruptive. You can always listen to meditation music, you can be in the zone. I have not met anyone who would not be able to, and I mean, like I said, we have 25,000 software engineers at Google. Everyone is able to work with the people next to them. It's just fine.
Okay, so next one. What did you do to get to where you are today? Your path to senior software engineer.
Okay, so it started with getting a degree in computer science, informatica, or something related. There are people that I work with that have a degree in physics, chemistry, or other science majors. I have sent my resume to jobs at google.com. I have received a call in 3 days, a phone screen, and 2 weeks later I already had the offer. And then I was just doing my best, I guess, working, being nice to people. That's very important. I mean, some people don't have, this is the one thing that we hire for, not only your technical skills, but also what we call googliness. It's a cliche sounding word, but being googly just means that you're not a dick. You are a nice person. You are not gonna quickly go into the elevator and try to close the door so that they don't delay you. You're not the one who's gonna take the last cookie in the dining room, right? We're trying to get the feel for people, and we try to work with people that are fun, relaxed, and when you work with people like that, it's guaranteed there will be much less drama. If you work with nice people, if you're nice to them, there will be less drama. You can just focus on work and not on drama. And look for interesting teams. I wanted to work on something important, so I worked on search for 3.5 years. I love Gmail, so I wanted to work on user-facing products, so I worked on Gmail for 3.5 years. Then I realized that I didn't want to commute to Mountain View, so then I decided I want to work from San Francisco office, and I transferred to what used to be called Google Wallet, now it's called Android Pay. And once you find the right team, it's fine to stay there, but we're encouraged to switch every 18 months, and we're encouraged to get promoted every 2 to 4 years. So we are we're expected to grow, and everyone is expected to get the senior software engineer. And some people are certain percentage of people will go beyond that, obviously, but yeah. I have a coworker here from Zurich, I heard. Where are you? Hi.
Okay, so now a kind of hard question. Google does open source by fork and keeps stuff secret, Ubuntu, proprietary Droid, or contribution hostile, Chrome. Will Google ever start doing open source right in the community?
What's the question? Gee, Google does open source by fork. Obviously, we're not going to open source everything. Why would we, right? There are things we don't want to open source. It's up to us what we do, right? And we keep stuff secret. Well, yeah, we want our security, details of our security to be secret, right? We don't want hackers to hack our Linux. So what is it that's surprising here? Droid contribution. What's hostile? Oh, we don't like contributors? Is that what he's saying? I don't know. I don't know if anyone's hostile. I've never seen anyone hostile for the last 10 years. Yeah, I don't know. Clearly something happened to this person, and I don't know the details of that, so.
You know, the problem is that 36 people liked this question,
yeah,
so.
So I guess people want to contribute, and it's difficult to contribute to the open source code. Is that the problem?
I don't know what was intention of the question, but maybe...
Or maybe he's saying this is not like real open source because
yes,
we control a lot, we still control a lot?
Probably that's the question.
Well, I'm not that high level, and I don't work for Chrome and those products where the decisions are made, so I can't really speak for that. I don't know. don't know.
Okay, so the next one. How fast the deployment is, how long it takes to have a feature shipped across multiple regions.
Oh, okay, so there's one thing to ship within the US, and there's a whole different thing to ship across multiple regions. It all depends on the product and what needs to be localized. And once we go into the different markets, there are lobbyists, lobby groups, there's their law that needs to be, we need to follow their law, there are things that need to be adjusted, terms of service need to be different. So that takes much longer than having to implement something within United States. And how long did these things take? So for example, Gmail, it started as a private, 20% project of this, one of my coworkers, and he just did it because he didn't like to use, I think, what did we use, Firebird? What's the name of that email client? We used some email client he didn't like, so he just created this thing, this web app called Gmail. And then we started using it locally, internally, as it had its own code name. When I joined Google, we were using it. It was called something else. And 3 years later, it was, or 2 years later, it was public. So I think it might take anywhere between a year and 3 years. But it depends. I mean, I'm sure Chrome wasn't developed that fast. It depends on the size of a project.
Okay, so the next one. What is Google's programmer-tester ratio?
So this is interesting. At Google, we have 3 roles that kind of fall in that category. We have software engineers. I think outside of Google, you call these people developers, right? Because we develop new features or new code. Then we have SET, software engineer in test. And then we have TE, test engineer. So software engineer in test, and test engineer. 3 different things. You're talking about testing, but all 3 of us are doing testing. All 3 different roles do testing. Software engineers are expected to write unit tests and integration tests for every feature they implement. So part of my work is to write tests for my own code and make sure make sure they work. Because how else I'm going to know for sure they work and all the edge cases are working, right? I need to think of the edge cases and write tests for them. But whenever I use some integration testing framework or something that I don't have time to implement, right? That's developed by SET, software engineer in test. SET is a software engineer that focuses on testing infrastructure, and they create testing infrastructure. Test infrastructure for testing Android apps, web apps, internal, anything for tests, any infrastructure tool for tests is written by SETs, and I use those tools, but I write my own tests. Does it make sense? And TE, test engineer, is a person who writes test cases, and they're different. It's closer to QA. We also have a QA, which is a manual QA. QA is like people, let's say, we have lots of people in India that do a lot of manual testing. Let's say they grab the phone and then they test the features manually, make sure they work before we push the new build. Those are QA. The test engineer would automate this. These are the people who try to automate what's done manually. Then SET, software engineering test, writes frameworks, which software engineers use. Does it make sense? Okay.
Okay. How many projects run PHP?
I don't know. I don't know. I've never heard of any. I didn't Facebook use PHP, I heard, heavily. No.
So one more, this one is kind of funny. How do I tell my PM he needs to throw a $50 kilo Jira license into a trash bin and create 2 spreadsheets?
Into trash bin and create 2 spreadsheets. So again, this spreadsheet is not created by the PM. You, as a lead of a team, tech lead, team lead, create your own way how you track your tasks. PM is there to tell you what they want to get done. You're the one who writes it down on a card or puts it in a spreadsheet or puts it in an icebox on the back of that whiteboard. Or if a PM wants some kind of report from you, sure, create a spreadsheet or something that gives it in the way they want to see it, right? But they cannot tell you how to organize your team because they're not engineers. They have different responsibilities. They're supposed to think about what the user needs and define the requirements. They are defining the requirements and giving them to you. They are not telling you how to do your job. I hope.
Okay, so last one, kind of quick one. How many developers from Slovakia currently work at Google in Silicon Valley?
In San Francisco, I'm alone. In Mountain View, I think we might have maybe 5, maybe 10. I know I used to be alone at some point. Then I referred another guy, which you might know from AngularJS, Miško Heveri. So then he joined. Then now he works, I think, with like 2 more Czech guys, and there might be more Slovaks there. There's a lady that works at the front desk. She's so new. She's Slovak. It's kind of interesting when you go to front desk to pick up your guests and you start speaking Slovak to them, and all of a sudden the front desk lady's like, "Vy hovoríte po slovensky?"
Okay, so that's all.
So that's Silicon Valley, but I think that we do have a mailing list, and at some point there were more than 100 people, but most of them were in Ireland, Dublin, and Zurich. And there are some people in New York City too.
Okay, so that's all. Time is up. Thank you for your talk.
Are there any questions from the audience? Or they use the tool? Okay.
They are using the tool, so it's kind of nobody needs to run with microphone around the room. So that's all. Thank you very much for the talk.
Thank you.
sea Avión. Jesús is a telecommunication engineer. He's very active in the Spanish Python community. He's a founder of Python Madrid and Python Vigo user groups and Python Spain Association. He's also involved in PyCon Spain conference. And he will talk about Python and DTrace. So stage is yours.
Hello, this is my first presentation in English, so please be gentle to me. Oh, thank you. Okay, this talk is going to be a bit technical, and all the slides are very packed with information, so I have a pointer to guide your reading. And usually I used to people to interrupt my presentation with questions in real time. That's not the procedure here, so I don't know how it's going to develop the thing, but let's hope that I explain the not obvious stuff I am doing. Okay? This is the overview of the talk. I am going to talk about DTrace. DTrace is a framework developed by Sun Microsystems in 2005, 10 years ago. They need a tool to help them to develop the Solaris operating system in a more evolved way that we used to debug programs so far. Okay? We used to do the famous print inside the code or breakpoints. But that's something you have to insert in your code and recompile all the system to try. Okay? DTrace is very different. DTrace is a framework where you define a lot of probes inside your code and you enable them selectively when you need them. Okay? They are always inside your code, running on your code. There are quite a few interesting differential factors. For instance, the sharing path, when they are not in use, the probes are always there, but they don't take any time if you don't enable them. Okay? And they are safe to use in production. You can even debug the live operating system in production with the machine actually busy. Okay? And it's available for quite a few operating systems, not Linux, well, kind of something to talk about later. The native versions are for Solaris and derivatives like Illumos, Open Indiana, Smart OS, and so on. The BSD family and Mac OS. Okay? So you have a Mac, you have DTrace. What does DTrace look like? Well, this is my system, my server. I am listing how many probes I have in my system now. This number, almost 300,000 probes I can connect to analyze how the system is working. Okay? That's quite a few probes. They can fire, there are different providers, okay? Providers for system call, provider for I/O, for virtual memory, for the scheduler, for devices, for everything. Even the program, the processes can create local probes, local to those processes, to provide information. See what else? Different probes. That's one. How do you use DTrace? DTrace, you have two components. You have the probes and you have the language. The probes are always there, covering all the system, including the operating system and the drivers, okay? And then you have a language, and not Turing complete language. It's a very limited language to activate the probes and to do some kind of processing when the probe fires, okay? like counting, checking the time, checking the process ID that's running, and so on. That language is very simple to understand. It's called DTrace. Well, the language is called D, has no relationship with the D language, so another different language. And I'm going to show a few examples of one-line debugging techniques. The first line is showing how many syscalls I can trace, quite a few. This is counting twice. This is counting the entry point to the syscall and the return, okay? When you go inside the kernel and when you come back. So you actually have half of this, okay? And I'm going to show you here a particular example of I'm going to plug into the sync syscall entry when a program goes to the kernel asking for a sync to the disk and print the name of the process. And this is an example execution, okay? Every time any program in the system is calling sync, I get a print line. I don't have to change any source code. I don't need to modify my system anyway. I just run this and I get a listing of all the programs doing an fsync. Okay? Live. But that's not interesting. I'm interested in knowing how long it's taking this call. Okay? And there's another example. Okay? I am plugging, activating this probe, the entry probe, okay? Saving the timestamp. The timestamp is the timestamp of the system at that time. I keep it in a local variable. And when the call returns, I summarize the difference, okay? So I know how long it's going to take, how long takes that call. And then I print the histogram. These are nanoseconds, okay? Most calls are very fast with a few outliers from time to time. This is so fast because this is running in a SSD disk, okay? A memory disk, so it's quite fast most of the time, okay? I don't have to touch any source code. This is running live in a system, okay? I can plug to a particular process and study the behavior of that particular process. In this case, this is an Apache web server, this process ID. I am plugging inside this process ID, okay? The entry point of all functions of that daemon. Quite a few, 20,000 probes that I can plug to. Okay? I can even analyze a particular library. In this case, I am analyzing this Apache process, but only the SSL library. Okay? I can monitor quite a few functions. And here I'm plugging to a particular function, and I am asking DTrace to show me the calls to this particular function of a running Apache process, and every time the process goes through that function, I get the profile. Okay? With no source code modification, neither change in the behavior of the process. This is an example of a dynamic probe, a probe that doesn't exist until you create it. This is running 1,000 times per second. I asking DTrace to create a probe running this many times per second, okay? 1,000. When it runs, it checks, this is conditional execution, this checks if the current process is this, and it's going to show me the stack of the process. I can collect this to, for instance, create a flame graph of a profiler, Okay? What routines are taking most of the time for this process? Again, without touching the running process. This is a daemon already working, already in production. Okay? This example is long, but it's easy to understand. I just trying to know how much CPU a particular process is taking. I launch a probe 1,000 times per second. If the process running at that time, I count it. And always I count the total CPU cycles. And I have the result here after a minute. More or less, this process is taking more or less 12% of the CPU, because this process, this example, is a CPU-bound process taking over an entire core, and this machine has 8 cores, so it's 12%. If you do the division, you get 12%. Okay? As expected. All of this is very interesting, but what's the relationship with Python? The problem with an interpreter language is that when you show the trace of a Python program, you don't see the trace of a Python program. You see the trace of the interpreter. The C code that is implementing the language, okay? That's not useful for a Python programmer. So a few years ago, I make a patch for the official Python interpreter to add probes to the interpreter to help a Python programmer to get information from the real Python program running, not the interpreter, okay? And those are the probes. You have the function entry and return. These probes are called every time you call a function or a method. Garbage collection start and finish to monitor garbage collection, and the creation of objects, okay? And every time you change line in your source code. When it's a trace, okay? With that probes, you can, well, this is the probes, you can have this. This is an example of, I want to know the trace of the caller of this particular function, okay? So I'm monitoring this Python process. I'm interested in the function entry for this library, the standard lib, and for this function, and show me the stack. And when the process calls that function, I can see the stack. From request, this is the request library, okay? From request, you get the stack. So you can understand how that function is used and by whom, okay? Only with a single line of, well, a long line, but easy to understand. Another interesting topic is what about garbage collection? When Python does garbage collection, but you don't have access to the details. You don't know when it's running. You don't know for how long it's running or how frequently it's running. But you can know using these providers. The provider of start and done garbage collection. In this particular case, I am just calculating how long takes a garbage collection. Okay? This is incorrect. This is not microsecond, but nanoseconds. This is nanoseconds. So it's around 8 milliseconds, 8 microseconds, 3 microseconds. All of this without touching the source code. And moreover, this is something you cannot easily know about your program, your Python program. You don't have access from Python. You don't have access to this kind of information. Okay. So you can understand the behavior of your program. You can check how often it fires and what function, for instance, is creating the most garbage collection invocation. Okay? Something that usually in a regular Python program you don't have access to. this is a memory leak detector. Here I'm just counting how many instances of a particular class are created, and when it's deleted, I just subtract one, okay? So basically what I have here is a counter for every class in your program, a counter of how many instances of that particular class are alive. After a while, you stop the program, the DTrace, and it's going to show you a summary of the state of your program. It's going to show you all the classes you have and how many references you keep. In this particular case, that was running for a couple of minutes, and in this particular case, there are 2 classes here created, probably just regular working. If you have several, you have an increased number here, then you have a leak. And you could have, for instance, using the stack provider, you could know where the objects are created. The objects you are leaking, where in what particular Python line they are created. Okay? Something that in regular Python you cannot have. You cannot know. Oh, more. This is a WSGI process in production. WSGI is a protocol to connect a Python server to the web, like for instance Django. Okay. Most WSGI is a module for the Apache process to be able to publish a WSGI framework. Okay? In this particular case, I want to know the sequences of call that happens when I make a request. So when I enter the application, I set a flag, 1. When I exit the application, the return, I delete the flag. And when I have the flag and I am going into a function, I just print it. Okay? So this line is going to print all the calls between entering the application and exiting the application. One line, and you know how your application is behaving for every connection. Okay? A problem I had once was I have a lot of threads and they were being blocked from time to time, and you don't know why they are blocked. They are deadlocked or they are waiting for something. Well, you have a provider, the scheduler sleep. This provider is called when your thread is going to sleep. When your thread is going to sleep because it's waiting for something to happen. Okay? So in this particular line, I activating this proof for this process only is going to show me the thread ID and the stack of that thread, particular thread. And I have here an example. I'm launching a future concurrent thread, and it's waiting in the queue, waiting for more work to come. Okay? This is something, again, something that in regular Python you don't have access to. And here is a single line of code. Another problem I had once was, my program was fast, except when from time to time was being slow, because it was hitting the hard disk instead of reading from cache memory. Okay? So we have this amazing provider, I/O. This provider is going to fire when your program is demanding something from the disk. You know that when you do a read system call, if you are lucky, most of the time the call can be resolved with cache information you already have in memory. Okay? You are not actually hitting the disk. But when you are hitting the disk, you want to know, and you have this provider that tells you. And this provider is activating this probe for this process, show me what line of code is firing that probe. In this particular case, the interesting line is this. Here I am opening any file in the operating system and reading it. The first time I do it, I get this, because it's actually reading from the disk. But the next time you are doing the same line, it's not going to fire because it's already in memory. Okay? So with this simple line, you know what files are you actually touching, what files are actually being slow. Okay? All of this without touching the original Python program. Can be a program you don't have the source, can be a program it's not yours. You don't need any collaboration from the program, okay? The program can help you. I'm going to show a couple of examples in the next slide, but you don't need to. The daemon is working in production. You don't need to stop the program, change something, and launch it again. The daemon is actually running all the time. You just activate the probes you need for a few seconds, get a result, stop the probing, analyze the results, elaborate how to keep investigating whatever issue you have, write a new DTrace script, launch it again, and so on until you find the answer you need. And the daemon process keep working. It's not aware of the monitoring. It's not the performance impact is something you cannot measure. And another interesting an advantage of this system is that you have visibility of all your operating system at the same time. You are monitoring at the same time the Python program and the operating system. Okay? You know what is happening in all your computers. You're not tracing just a program, you are tracing the entire operating system. Okay. I told before that you don't need the collaboration of the Python program, and you don't. But if the program helps you, you can get more information more easily, okay? And there is this other project. This is not mine. I am not connected to it. This is the Python USD, because this is the meaning, okay? Static defined tracing. These are probes that the programmer write into the original program to help you to debug, okay? An interesting example is this. The FBT. FBT is a function boundary tracer, okay? So you can monitor a particular function when you are interested. In this particular example, importing, and this trivial example is decorated with this, so it's going to publish a new probe for this program and for this function. Pay attention to this. Here I get the process ID, and here I calling the function. And in another window, at the same time, I am asking here for the probes I have. I have two probes. The probes I just created, okay? I am calling the function, and I get here, I have the entry and the return, okay? So if the program helps you, you can get far more information. You don't need it, but the collaboration is helpful. Okay, about the future, 2 minutes, yes, I need the reminder. The future. This is production ready, already for quite a few years. It's working in Python 2 and Python 3. But more work is needed. I do most of my work on Solaris and Solaris family operating systems, but DTrace works in macOS and the BSD family, okay? And I need somebody to take care of that. So tomorrow we are supposed to have a sprint to try to get this thing working on macOS and FreeBSD. So you can join, you are interested, okay? And I want to add more probes for more interesting areas of the interpreter that you don't usually have visibility into, like the yield, the global interpreter lock, and the synchronization primitives in the threading module. Okay? And this is something to ask if you want to embarrass me, you can ask this. And this is the sample of the performance. This is the real assembler code that is running when you have a DTrace in your program, okay? DTrace pros. Here is when it's not enabled, and here you enable. When it's not enabled, you have this 1, 2, 3, 4 instruction with taking no time to execute. So this is a proof that the performance hit when you are not using DTrace, DTrace is there, but you are not using it at this moment, the performance impact is very, 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 very tiny. Okay? This is tomorrow sprint. This is documentation. And this is something I used to do when I have a presentation. I suggest questions, but it's not going to work in this environment probably. All of these are real questions, difficult to answer. Very interesting. And that's all.
Okay, so now for the question part. Are there any Python libs that build on top of DTrace at all to provide high-level view of a running app with collected stats, CPU time, slow FNC, etc.? GUI?
There are a lot of tools that are not related to Python. That is, when you are interested in these things, in CPU time, for instance, that's a problem to solve to any kind of programs. And DTrace is not connected to Python. Okay? So any script already made to monitor the CPU use of a program is going to work with Python too. But the tools are not in Python. Okay,
okay, the next one. The DTrace commands looks quite complex in one line. Is there a way to make it more readable, understandable?
Yeah, of course. I am writing the one line, very long line, but you can actually use several lines. You can write it in a file and execute the file. Okay? In fact, there are quite complex DTrace scripts around. Can be pages long. So yes, it's easy to write in a more legible way. Yeah.
Okay, next question from Pavel. Is there any way to use DTrace on Linux?
Just here, that question is here. Okay. Okay, the thing is this, DTrace is open source, but it's not popular, okay? It's not in Linux, there are two choices, basically. You can use Oracle Linux. Oracle Linux has first class support for DTrace, but well, Oracle is Oracle. Let's say you are recording the talk, so let's say it's painful, okay? Painful to use. And there is another project for a GitHub guy porting DTrace as a kernel module. Okay, I never use it. I don't use Linux, but it's supposed to work. There is a link here. Here, okay, DTrace on Linux. Next.
Okay, so two last questions because we don't have more time. Can I DTrace segmentation faults?
No. DTrace is safe. Well, I don't know in Linux, I don't know. But in the real operating system, there are real operating systems out there. It's safe to use. Solaris team used this to improve the operating system. So it's it's safe even to an operating system level debugging. Okay? In fact, the DTrace language has only read abilities, cannot write except if you activate a dangerous flag. That dangerous flag allows you to kill processes, stop a process, modify memory. But that's something you have to enable in the command line. By default, you cannot touch memory. You can only read.
Okay, so the last question from Martin. When should we use DTrace when developing Python applications? What are the ideal use cases for using it?
The ideal use case, in my opinion, is when you are finding problems you don't know how to debug or you don't know how to analyze. DTrace is amazing because you run it on a already running process in production, and it's very iterative. Usually you have an idea of what's going wrong in your program. You create a single line script to validate that hypothesis or hypothesis, and when the results, you refine the debugging and you explore the behavior of your program with the program in production. So I think you don't usually use the trace when you are developing the program. You use the trace when the program is already in production or you find that things are not going the way you expect. Okay.
Okay, so that will be all for today because we are out of time. So now the break and then the next talk. So thank you for the talk. there will be lightning talk session. So our next speaker is Scherer. Michael works on the open source and standards team at Red Hat, focusing on infrastructure issues of various communities as a system administrator. A long-time packager and Python coder, he lives in Paris when he is not traveling to speak at the free software events around. So, big applause to Michael.
So, thank you, and welcome to my talk, which is the last one. So, well, I wanted to speak about myself, but basically everything was already explained, so I will just repeat, blah, blah, blah. Sysadmin at Red Hat, so I'm basically working during the day on various projects, and also during the night, because I'm working with projects all around. That's why I look like I didn't sleep. It's because I didn't sleep. And we had some problem this morning, that's why I missed the first talk and this kind of stuff. But I'm not here to complain. I mean, French has already a bad reputation about that, so I will try to avoid that and speak directly about security. So security is quite, well, it's a word that can be used for various stuff, from getting a budget from your boss because it's a security issue, we need to get more budget, or just the stuff that you forgot to do. I will just focus on the definition I got in university a long time ago, which is basically around the letter CIA, which is not the Central Intelligence Agency, you know, the bad guy before the NSA. It's about confidentiality. So the C is for confidentiality. Confidentiality is when you go to a website, let's say some extramarital dating website like Ashley Madison, and someone managed to get access to that and publish the database, again like Ashley Madison. That's a confidentiality issue. Integrity, it's another kind of a security issue, is when you go to your website, the website of your bank, and someone just decides to send the money around, for example, to my own bank account, and if you do that, I will be thankful, but it's an integrity issue. The integrity of your bank account has been, well, breached. It's the same if suddenly someone decides to change a website, for example, the website of this conference, and decide to replace all the information with a nice skull spinning with a flame, you know, like what we see in movie, and also in real life. So that's an integrity issue. It's not, sometimes it's with confidentiality issue, sometimes it's not. And the last one is about availability. So availability is when you try to go on a website and it's not here. So for something like PyCon.sk, well, it's quite problematic, but not so bad. When this is a shopping website, suddenly you are starting to lose money. And I don't know how stuff works all over the world, but I'm pretty sure that if you lose money, then you do not get money to be paid, and it's quite bad from a professional point of view. So that's something you try to avoid with security. There is a lot of definition, but most of the time it's also about the different level. If somebody publish, let's say, something that do not matter, like the first name of the speaker, of the surprise speaker of a conference, well, it's not a big problem. Suddenly you publish the password of everybody at Facebook, then it's a bigger problem. So to avoid that, you can work on infrastructure, which is my day job, which is making sure that everything works fine. Usually that's setting firewall, web application firewall, SSL, etc., etc. Most of the time it's about configuration, and configuration for confidentiality, integrity, redundancy for availability. For example, if you have only one single server and it's not in the cloud or something fancy like this, and someone starts to put some coffee, I mean some real coffee, like not some Java. I mean, I like Java, but I do not want to trash it. So usually most of the time servers do not work that well anymore, and with enough coffee it can completely crash everything. So that's where there is redundancy. You just set 2 servers and that's it. If possible in 2 data centers, and if possible in one where people are not authorized to put coffee on other people's servers. So that's part of my job, and there is, well, everything else. And we are at PyCon, so we are gonna speak about code. It's not a secret. most computers are running code. Most code has a bug and problem. And most of the time, when you write something, you need to deploy. I mean, because it's fine, you can write some code and do not use it. It will not be more secure, but at least it will not be more problematic. Most of the time, you have to deploy it, which is install, upgrade, and everything. And it turned out that most of the time, an upgrade is not free. I mean, it takes some time. Sometimes it's 5 seconds. Sometimes you need to get approval from the vice president and everything and get all the partners to decide if some patch needs to be accepted or not. Sometimes you cannot even upgrade. I mean, have you already tried to upgrade the software on a plane or a pacemaker? It's more complicated than you may think. So the idea is that some upgrade can cost some money, some time, or cannot be done. So you need to make sure that you detect problem before, which is obviously as soon as possible. If a problem is present in the code base for 5 seconds, it's much better than if it's 5 years. If people are running Linux or following the news, you may have seen some problem about OpenSSL, like last month, last year, the year before, or anytime soon. What is good with OpenSSL, I can keep the same slide for several years. So we want to detect that as soon as possible, and for that, most of the time we use a static analysis. In the case of C code, it will be something like CLang, which is coming from a LLVM project, Coverty, or other project. There is no project called etc., just to make sure. But most of the time it's focused on C. It's not because C is a bad language, despite what people say, it's because it's a widely used language and there is a lot of problematic code. And there is fewer tools for Python, except that now we start to have a big code base in Python from Zope, Django, and everything. So some people started a project called Bandit, and it was started by the OpenStack security team. So OpenStack, if you do not know what it is, despite having done a lot of buzz in the 5 years last year, it's a big infrastructure as a service or whatever as a service project. My own employer did invest a lot of it, so you can go ask to people at the booth about it. They will be quite happy to explain. And it's a million and million of line of code, and the security team was tired of all the security problem to be fixed and everything, so they decided to create a tool which is, well, just a big blacklist. So it uses a Python module called AST for abstract syntax tree. So I guess that there is some student in the room, maybe some of them did compiler design, so go ask them what it is, because I didn't. I was rather playing Quake at university instead of listening to my teacher. But from what I understood, you take the Python source code, you transform it in some kind of, well, syntax, which will be abstract, hence the name, and then you can read it without parsing all kind of variation for string and everything. Because if you do that, you are likely to miss something. Using the AST is much better. It's an intermediate representation. So you just say, yeah, if you see that function, then do something. So from a purely technical point of view, there is not much in the tool. It's just a blacklist with a list of insecure stuff, and we will see later some example. You can use your own plugin if you want to get some kind of construct that you know that will be insecure, but that is very specific to your own code base. Well, you can do it. So the problem with this approach is that there is a numerous false positive, so you need to make sure that you understand what is going on. That's why there is various alert severity, from critical to maybe there is something fishy. So let's take a look at a few examples, because everybody speaks about security, but it's much better with example. So let's start with the YAML module. So for people who do not know what is YAML, it's a language to describe data. I do it like every day. I'm using Ansible for my work, so it requires that. And when I'm not using Ansible, I'm using Salt, which also uses YAML. I love it, but there is one single problem, is that in 2 lines of code, suddenly, depending where the string is coming from, well, you can have a security issue. That's a security issue that was found first on Ruby on Rails. Basically, the problem is that So for people that do not fluently speak YAML, that's a serialization of an object, and that will execute the code, which is a for dot directly when you just load the string. So when the YAML is written by the sysadmin for himself, usually we do not do this kind of stuff. When the YAML is coming from, I don't know, someone on the internet, well, maybe you do not want people to just start to send arbitrary code in your process, because you know they might start to do something like bad stuff, stealing SSH key, SSL key, stealing password, inserting more money on their account or moving money and this kind of stuff. So that's the kind of issue that will be detected. YAML load, as seen there, is insecure depending where the string is coming from. The same goes for SQL injection, which is a well-known problem, but you look at this, you say, well, it's fine, it's verification of a username, and where is the problem? Well, the problem is that if someone starts to use that, then we get a more complicated query, which is not at all what we were thinking about, and suddenly people can get admin access without having them, which is, well, bad. So usually for that, you need to use an ORM, for example, the Django one, ORM for Object Relational Mapper. There is SQL Alchemy, there is a lot of stuff. Do not try to do your own by yourself, because it's a lot of potential problem, and why reinvent the wheel when someone did the job. Same goes for cross-site scripting. That's when you return JavaScript to the users. So you get a form on a website. Websites are quite great because they are connected on the internet, so lots of people can access it, and they spend their time getting all kind of input from a random stranger. So that's where you get a real interesting security bug. So that's basically when you just enter something, and instead of giving your name, you just give the JavaScript, and then there is something that say, hello, your name, and it prints JavaScript. So that's quite bad. That's a common problem. And it's even a more common problem because of Jinja. Jinja is a template language. I assume that people might know about it. It's similar to the one used by Django. It's quite popular. And by default, well, there is no protection because it can be used for more than web page. So the developer said, yeah, we want to use it for email, for all kind of stuff. So by default, it will not be enabled. And it turned out that people do not know that there is no protection by default because some other template do provide it. And that's the kind of stuff that a bandit should be able to check. Then comes my favorite type of problem because I keep finding them, well, all over the place. For example, I was in the plane coming from Paris, I'm from Paris, to Vienna, and I had no internet access, and I was bored, I forgot my book. So I decided to read some source code. I know it's weird, but that's the only thing I have on my laptop. So, and I found a security problem based on /tmp. Basically, the problem is that you have a script. Most of the time, it's a script, which start to use something in /tmp, because, you know, /tmp is on every Linux system. There is no problem, anybody can write there. So it's like perfect, you do not need any kind of complicated installation. And so they start to, most of the time people do stuff like log there. But if you know the name, someone can just make a symlink, and suddenly you are starting to write in a file which is not the one that you were thinking about. And that's quite common for a problem. I did find like one every month or something. And there is various ways to avoid it, but it's better to not have the problem in the first place. Sometimes it's just a denial of service. Sometimes it's escalation and everything. So again, that's something that Bandit can detect. It can verify if you are using SSL v2, which was bad when the first time I made this presentation south of France. Now it's even worse, given the latest OpenSSL security problem. It checks if you do not verify the certificate. It checks if you are using Marshall, which is something that can be used to serialize an object. So if you are reading arbitrary object, maybe you will be reading an object that is not the one you think you are reading. The same goes for pickle, for exec. As soon as you start to exec various software, maybe you will see some issue, etc., etc. And most of the time, it's always the same kind of problem. You have a data which you think is a string, but suddenly it's not a string. It's a string and a SQL command. It's a code for HTML and there is JavaScript, etc., etc. So let's assume that I convince you to run bandit because, well, I hope that you will do that for security. What to do if you find something, because you take your code, you run it, and boom, it shows a lot of stuff. Well, first you need to estimate the problem. As I said, there is a lot of false positive, like basically each time that something is using exec, you will say, yeah, maybe you need to check that, maybe you need to check that. So most of the time it's fine, sometimes it's not. So for that, you need to read the source code. I will assume that you have the source code, mostly because bandit do not work on anything but source code. You need to check the severity, like is it something which will be bad or not? It can be quite complicated if it's your first time, but you can see for very small stuff like just cross-site scripting, it's quite easy to see that if you have cross-site scripting, then it's bad because people can steal session cookie, people can just make all kind of remote call with Ajax and everything. So do not, if you just see that there is a problem, do not go further away, just say it's bad. You can contact a specialist. It's quite easy. You just find them in some security conference or some dark place or this kind of stuff, or on the internet, just trolling each other about antivirus or this kind of stuff. Ideally, you can contact the project, if possible in a private way. That's usually where I insert a GitHub warrant, because there is no private bug on GitHub. And most of the time, people do not publish their email, so they do not get spammed. So you need to do some work to find who to contact and everything. If you do not want to do that, you can also just publish that. Maybe if you will become famous, most of the time you will just be ignored. What you need also to do is to get a CV identifier. So a CV is just a number. It dates back to the time before we started to give name to a security problem. And most of the security problems have just an identifier. So to get that, you can request to Linux distribution. Usually I just go to see to people from the security team at Red Hat, because, well, we are working on a Linux distribution, so I can directly ping them. If you do not want to contact a Linux distribution, or if you are just using Mac OS X and you do not know what is Debian, SUSE, or Ubuntu, and you think it's just Pokemon name, well, it's fine. You can also go to the list open source security, which is OSSSec on openworld.net, I think. And you just say, yeah, I found that security problem, can I get a CV? And maybe you can get one in 1 or 2 weeks, depending on the load of people who are supposed to do that. If you are reading Linux Weekly News, there is a good article at the moment on the topic. So I will not rehash that. And I want to remind that bandit do not do everything, because it's nice to do static analysis, but it can give false positive, and it can also avoid to detect something. If bandit detect nothing, that do not mean that your code is secure, that just means that it detected nothing. So to example, as part of my job, I'm trying to help people from the website softwarecollection.org. If you are running CentOS or RHEL, it's quite a nice website that provides a backport for various stack like Python 3, Ruby 2, everything and everything. And they called me because they needed a sysadmin. And it turned out that, contrary to some other projects, they did everything well. Like, everything was properly administrated, there was a firewall, there was backup, SL Linux, and all kind of stuff. But they still managed to get one very, very specific problem that I just put on the slide because I do not have enough space to put the diff. And it was just a specific problem with an injection in an RPM build. So for people who do not know what is RPM, it's the package system of Red Hat and other distribution. And it turned out that the website was creating a RPM directly on the web server, which is, well, bad, but not so bad. And using an obscure feature that I know because my roommate was working on RPM, well, I was able to technically, because I do not test on production, or at least I pretend I do not do that when there is a camera filming me. Technically, someone who would have detected that would have been able to execute code directly on the web server, which is bad. And it turned out that, well, no one did, because you need to register to create a repository and everything. It's like, there is a lot of audit, so we did see that no one did anything. But yeah, that's quite bad. And I found that just by looking where there is some code execution, and it turned out that this one was, well, working. The second one is Epsilon. So I like to boast about myself, but this one is something that we found before breakfast. Like I was discussing with someone in a Fedora conference, and before we get to breakfast, we found something. So Epsilon is a provider for SAML, OpenID, Persona, or whatever authentication. The bug is this one. And basically it's just that they forgot to add some code. Like there was an operation that should have been restricted to only the admin, and it turned out that they forgot to place the restriction. And yeah, basically bandit cannot detect code that was not written for security purpose or anything like this. And in the end, if you want to find more information about the whole topic, so you can go on owasp.org, which is a website dedicated on listing all kind of theoretical stuff about security vulnerability, like all kind of obscure stuff, like LDAP injection, which is the same as SQL injection, but when you are using LDAP, buffer overflow, all kind of stuff with sometimes good examples, sometimes bad example. It's a wiki, so it's like Wikipedia without the Pokemon and focus on security. You can also learn about this by reviewing security patch. So that's easy. You just see a software, you just wait for an update and see if there is a security patch. That's why you need to make sure that you get the CVE ID in the changelog, so people do not have to check everything in Git log. I do that from time to time. I used to be working on a Linux distribution as a packager. And when we have to backport the fix, it's much easier when you see, oh, that's this changelog in Git, in Mercurial, in CVS, or whatever. Take the code and try to adapt it, then read everything that was done since 2 months and try to find where is the security issue. You can also check the update list on Linux Weekly News. It's like every day of the week, so not on Sunday and not on the weekend. And you can just check and you see, oh, that software, I know about it. Maybe I can check what is the problem. You want to learn about PHP, just wait until there is some problem in WordPress, which happens quite often. If it's not WordPress, it will be Drupal or any kind of CMS. And last, well, you can start your own audit. You just do that by yourself. Just take a plane to Paris, come back to Vienna, and when you will be flying, you have no internet access, so you can do that. That's what I do. You need to check critical code. So critical code is code that either deal with authentication, because that's where interesting stuff happened, or code that take untrusted input, which is basically everything coming from the user and the user or other system. And that's it. So I was faster than expected, according to my clock. So if you have any question, maybe it's the time. And if you are too shy, you can contact me on mail, because I have no Twitter account, no LinkedIn account or anything. Or you can just ping me on IRC. I'm there, well, almost every time, because as soon as I have internet access, I do have access to IRC. You can contact on my mailbox at redhat.com, or if it's something that you want to keep more private, you can use zarb.org. And that's it. If you have any question, it's the time.
Okay, so the first question, can you show a small live demo of Bandit in action?
No. Well, I can, but okay. Do people want a demo or not? Because maybe it's not the... I'm not here tomorrow, so I cannot do a workshop, but maybe you can do one. No? Well, I can try to do it, but it will be complicated. That's not very nice to say that. Nope. Oh, nope. Oh, good. So, first let's check if it's installed. Nope, it's not installed. Sorry? Yeah, but for now it's not working because it's, well, not installed. So no, I cannot make a demo. Or at least I can make a demo, but as expected, it do not work. Next question, sorry.
Yes, you did a demo of missing module.
Yeah.
So the next one, can you clarify what's wrong with writing into TMP directory? Do you think it can be dangerous even if you don't write any sensitive data there?
So with TMP directories, the problem is that everybody can access it. For example, let's say that I have a web server, like just some test web server, which is deployed in production, and I deploy on a server where people do have access. For example, shell servers that, as we can see in a university, or as we can see in, for example, the federal infrastructure. And you decided that it's easier to write the log on a /tmp log. So you start the web server, and it writes everything in /tmp log. And you do not check anything, but someone decided to just make a link between that and some user account. So that means that the log will be written in the user account on an arbitrary place. Then the only thing I need to do is to push something in the log, like a request. It's a web server that looks like some file. For example, let's say a SSH key. And if I manage to write that in a .ssh authorized key, well, suddenly I can write arbitrary keys there. So that's the kind of security problem you can see. If you are running that, it's mostly a problem for a shared server. Most of the time, it's not a big issue. But if someone gets access to some application, because there is a problem in one application, suddenly you can start to crash other application, execute, make some kind, just, for example, you are a student, someone has your thesis, you do not do backup because backup are for WIMP. That's what other people say. And someone just managed to to replace that with the log of the web server because of the so-called symlink problem. Well, sorry, you have to start again. And that's the kind of problem. Sometimes it's mostly harmless problems, that's why people do not fix them. Sometimes it's the system do not start again. Like if it cannot open the log file because someone changed the permission, well, maybe something will not work. You reboot your server, it do not work, and in the middle of the night you start to get a text message from Nagios, and I can tell you that you do not want to get text message in the middle of the night. At least I do not want to do that. So yeah, but I hope that's a good answer. If not, I can explain, just send me an email and I will be happy to give more pointer and all kind of crazy escalation paths around this kind of problem.
Using cloud services, GitHub, Travis, etc. versus self-hosted Jenkins GitLab for development from security point of view.
Okay, so the question is using Travis versus self-hosted for security point of view. For a CI system, well, from a security point of view, I tend to prefer, I'm a sysadmin, so obviously I will say, yeah, do your self-hosting because that's more work for me. And I want to make sure that I get a job. Then it depends. I use Travis for my own stuff because I do not like Jenkins. At the same time, you cannot do a lot of stuff with Travis. I need to test stuff on CentOS. I cannot do that with Travis. Or I need to use Docker, and then suddenly I have another problem, which is Docker. At the same time, well, Jenkins is problematic for several points of view. For example, the RPM are not served over SSL. The security bugs are found quite often, and they are quite scary. And well, it breaks quite often on upgrade and everything. So I will tend to say to people, if it works on Travis, use Travis. If it works on Jenkins, use something else, like Buildbot, which is Python, so it's better by definition. I'm just saying that because we are at a Python conference, just to make sure if some Java guys see that.
Okay, so the last one, what kinds of issues can Bandit detect in Python code?
Well, all the issues that I showed in the presentation. I do not have the exact list. It's written on the website, which is somewhere on OpenStack. I can go read the source code right now, but I think it will not be a good answer. So just see again my presentation and see the website and the documentation. Sorry.
Okay, so that was the last question because we don't have time for any next questions. So thank you. In French, it would be merci beaucoup, yes?
Yes, exactly that.
So.
Thank you. Yep.
which is Miloš Šrámek Open Source Weekend. And by the way, lightning talks could be in English and in Slovak, so we don't have any preference for those who prepare them in Slovak, as I announced yesterday. They could be, or Czech, of course. So, yeah, please go to the microphone and let me know if you are ready.
Thank you very much. My name is Miloš Šrámek. I am from the Society for Open Information Technologies, and I will continue in Slovak because this is an announcement of an event which will be held here in this area in a month. Takže ešte raz po slovensky, moje meno je Miloš Šrámek, som predsedom Spoločnosti pre otvorené informačné technológie a o mesiac na Univerzite FMFI-UK sa uskutoční Open Source Weekend. Je to prednášková akcia dvojdňová, odznie tam 26 prednášok s témami od veľmi všeobecnými, napríklad čo nového sa chystá v distribúciách Red Hat alebo OpenSUSE, až po veľmi špecifické technické otázky administrácie. Ja to tu mám napísané pre istotu, ale nemám okuliare. Proste, dozviete sa mnoho zaujímavých vecí o svete otvoreného softvéru. Jedna sekcia bude venovaná open source hardwareu, budeme tam mať témy ako je Arduino a open source hardware všeobecne, plus bude tam workshop, kde organizátor donesie asi 20 Arduín a keď si donesiete svoj počítač, svoj laptop, tak môžete sa s ním pohrať. Veľkú časť budeme venovať otázke nasadenia otvoreného softvéru v organizáciách a teda niekoľko prednášok bude tomuto venovaných a v sobotu podvečer sa uskutoční panelová diskusia, kde viacerí ľudia, ktorí s touto témou majú skúsenosti, budú hovoriť o týchto svojich skúsenostiach a možno aj o tom, že čo by mohla štátna správa v tomto štáte urobiť preto, aby trošku ušetrila z tých stoviek miliónov a použila ich potom nejakým rozumnejším spôsobom, ako vyhadzovať na zbytočný softvér. Ďakujem pekne.
Ďakujeme pekne Milošovi. I would like to ask Filip from Poland to introduce us PyCon PL. Just 1 second while they set up. I will reset the clock. Okay, so are you ready?
Okay, so I will start. I will talk about PyCon PL. That's the list of PyCons in Central Eastern Europe. Actually, PyCon PL is the oldest one, so it was started in 2008 already. Slovak one is the youngest one, but I'm very impressed by all the organizers' work on the conference. It's really good. For a first conference, it's a big success. So PyCon PL, it's a conference that moves from place to place, and probably you noticed that the names of the places aren't big cities. So we had the general idea that we will organize conference in the small town villages instead of big cities, but in hotels, of course. And we are generally always looking for big hotels so we can fit all the attendees in one hotel. So usually it results in making PyCon PL in such kind of places. And what are the advantages for the attendees? So first of all, you don't have to worry about your last tram bus leaving, or that you forgot something in the hotel and you need to go back. You generally don't need to worry about weather because you are staying in the hotel, so you don't need to move outside. But if you want, you can go hiking. And everything is close. And thanks to that all people are in one place. There's great opportunity to socializing. So that's the official date for PyCon PL 2016. And it's the first place where this date is publicly announced. So it wasn't known earlier what will be the date this year. So where exactly is PyCon PL? It's in a village called Osa, where there's a huge hotel complex that can even fit 1,000 people in rooms. So it's 1 hour from Warsaw, and you probably ask how far away it's from Slovakia, from Slovakian cities. So from Bratislava, it's around 6 hours if you travel by car. From Košice, it's similar. But if you do not plan to go by car, you only need to reach Warsaw, as we from the last year we started to organize bus transfers, so you can use them. And to reach transport, you can use trains, or you can, if you want the super cheap option, then you can pick a direct bus line from Bratislava to Warsaw, and return ticket costs around 30 euros, so it's very cheap for such a long distance. You can also take some flights. So PyCon PL, lots of tracks, lightning sessions like here, from 600 to 700 attendees we are expecting this year. Last year we had over 500. And the full ticket includes hotel, which is 4-star, and meals during the conference. We are cooperating with organizations that are promoting diversity and organizing the conference. We also had lightning talks. You see, PyCon SK was advertised during the last PyCon PL. A lot of people. Other activities. We have a coding contest when you can win valuable prizes. Last year you could win drones, smartwatches, and smartphones. We have board and card game nights. This year we will have a retro zone, so with the old computers and consoles. There's always a grill barbecue on Saturday. If the weather is bad, then it's the grill dinner. Some photos from the PyCon PL, so you can have a feel how it looks like. A lot of games, some Czech people playing also, some workshops from Agile with Lego. That's the place, how it looks, so the restaurant. There's a free swimming pool, jacuzzi, sauna. There's a bowling pool, so a lot of attractions and opportunities to integrate. And the full price with the room is, I would say, it's quite cheap for 4 days. It's around 200 euros. So that's all. If you don't have the money, apply for financial aid.
Thanks, Philip, for the introduction, and I need to check the next speaker.
Yeah. Jirka Bayer.
So Jirka Bayer will be the next speaker.
So, hello everyone. I guess this is the first speak today and yesterday that's done from an Android device. And what I would like to talk about is how to easily run Python on an Android device without root, with stock ROM, without any difficult modifications, and completely open source. So my name is Jiří Bayer, and let's start. So recently I've discovered a tool called Termux. It's a single-user Linux environment, or Linux-like. It's a terminal, emulator, and multiplexer, so you have multiple consoles at the same time. It requires, unfortunately, Android 5.0 plus, but it doesn't require root. It provides Debian package management, so basically you have apt, you can download from a remote repository a list of packages, install it over internet, upgrade them, etc. And it has some extras like Android widget, which can invoke actions within this environment, and wrapper for Android API, so you can, in theory, have access to sensors and stuff like that. The homepage is termux.com. It's available for download from fdroid.org or Google Play, but as this is open source application, fdroid is the preferred way. This is a screenshot or a picture taken from the Termux homepage, showing just basically an Android phone with 4 cores running colored top, so it looks very fancy. And basically, the Termux provides a package for both Python 3.5 and 2.7. It's available on the repo immediately for download. Pip works out of the box, Git as well. It's again available as a Debian package. There are some basic editors. Everything is text-based, but ncurses are supported. So beyond Vim, Python, and Nano, we have also MCEdit. And as the application is running as non-root in the Android environment, we have only higher ports than 1024. But the traffic is available, the traffic or the applications running in the environment can communicate with Android applications like browser. The file system is a little bit unusual, but it breaks shebangs, so there need to be some hacks to make it work, but it's usable. Goodies useful for working with Python in this environment is Bluetooth or Hacker's Keyboard, and it's possible to theme the bash and syntax highlighting in Midnight Commander. So what I would like to show is really quick live demo. So this is a running Termux environment. First of all, if I type apt update, it's connecting to the network. Apt upgrade. It really shows something and it starts downloading and installing. So before it finishes, PWD, it's visible that I'm not in the regular hierarchy for Linux systems, but rather Android. And another quick demo, this is Midnight Commander with syntax highlighting tuned for Python syntax, so it looks like base 16 dark. And the last very short demo is this very short application. It's actually Flask demo app, so it doesn't do anything more than hello world. But if I start it, yeah, it's running, and then switch to Android browser. So, oh, once again. So now I'm connecting to localhost 5000, and hopefully it will serve the hello world. But as it crashed, I'm not sure if it does it do 404, but it's only favicon. Yeah, it works. So that's it. Thank you.
Thanks to Jiří for Termux and Python on Android. I would like to ask Korenčiak to tell us something about Django and ako spravovať komplexný settingsy. So I guess this one will be in Slovak.
It will be in English.
Okay.
Okay, that's it. Oh, so several times when you manage your Django settings, .py files, maybe you have there some settings for more machines, and it gets too messy. So for this, there is one simple hack I have found once, and it is creating the directory from the file settings.py, and of course you need to get there the init.py of course, there should be underscores, but this environment eat that. And in that init.py file, you can do some magic things. For example, you can decide on which environment you are operating and import another files in that settings directory, and in this way you can manage it, and it doesn't get so messy. This is also usable on another places where you need to have a lot of some specifics in one file. You can just split it into more files in one directory which have init.py. Another flash which I hope will enlighten you, for example, is about NumPy, which we're told about today morning. And there are also some 100 challenges which aren't so easy. The first ones, yes, but when you are going down, there are more hardcore examples when you can see some ways to use this NumPy, how to work more quick than you could understand sometimes, because there are hacks which are possible. So that's another one. Next flash, there are also NumPy challenges. Yes, I'm NumPy developer. Not NumPy itself, but I'm using NumPy for developing some software. And the last thing, you can use, for example, this IPython notebooks for presentations also. For example, this way, it can create slides. And this one package and be present. This is it. It's GitHub, can be used for that. So, for example, if you want, you can try. Thank you.
Thank you very much. I would like to ask Rodolfo to tell us something about Coding Dojo. Okay, so Rodolfo and Tatiana. So, welcome.
Hey, hi everybody. I'm Rodolfo. I work for Red Hat. And?
I'm Tatiana. I work for Education First in London.
Okay, we are gonna talk to each other because we have 5 minutes to spend. So Tatiana, what are we gonna do tomorrow?
Oh, tomorrow I will come here to join the Coding Dojo.
Yeah, what's that?
Well, it's a kind of activity where people practice pair programming, and we train tests, and we learn best practices. We can learn more about Python programming, and eventually we might even solve some problems together.
Oh, that sounds really cool. I really want to learn more about TDD. So I'll probably join you. How much does it cost?
It's for free.
Oh, really?
It's free of charge.
Oh, great. So what time are we starting?
We should start around 9, and it will be from 9 to 12. We will be here.
Okay. That sounds good. What else? Oh, we still have time, right?
Yeah. What about you? Have you ever joined any Coding Dojo?
Oh, yeah. So, yeah, actually, back in 2008, I was in PyCon in Brazil, and I had my first Coding Dojo there. It was incredible. It completely changed my life. And we started a Coding Dojo in Rio that runs every Wednesday. And it's so, how many years since then? 8 years. Oh, that's crazy, right?
Yes, if they're keeping it, it's a good sign.
You know what? I also started a Coding Dojo in Brno. It's been 8 weeks so far. So if you are a Czech guy, well, maybe talk to me, and I would like to meet you in Brno for a dojo. How about dojos in London?
Well, I've joined around 2 of them, organized by random people, and were quite awesome as well. Yeah. So there are a few meetups around the city where you can join and learn and interact. Yeah.
So great, guys, if you don't know what to do tomorrow, so come join me and Tatiana for the Coding Dojo. Thank you.
Thank you very much. That was definitely interesting. You should try it tomorrow. I would like to ask Miro and Harris to come down here and tell us something about porting DB.
Your mouse is down. Can you hear me? Excuse him, he doesn't know how to control his own laptop.
Yeah, something like that.
So, yeah. So, hello, I'm Miro. This is Harris. We want to tell you something about porting DB. This is not porting DB. This is Python free wall of superpowers. You might know this actually as the list of favorite packages from Python package index. And they are sorted by downloads, and they are green if they support Python free, which is pretty cool. As you can see, the first few of them are green, and if you don't scroll, you can get the idea that everything is fine. The problem with this list is that not every Python thing lives on package index. A lot of apps don't live there, and also a lot of for example, if there is a C library or a C++ library that also generates Python bindings, they often are not to be found on Python package index. And we are from Fedora, and we love Python 3 and we hate Python 2, and we want to make the world the same. And we want to port all the Python packages to Python 3, but of course not only by ourselves, but
we need more contributors for that, first of all. And secondly, the newest Fedora version will actually have by default Python 3. Python 2 is considered actually legacy at the moment, somehow at least. All the new features will be in Python 3 at the moment, not in Python 2.
Okay, let's show the porting DB.
Porting DB, it's a project from one of our colleagues, actually, which tracks from the Fedora package database, which packages are actually upstream ported in Python 3, which are being worked on for Python 3, and which are actually not being worked on. The blue thing is
just jump there. You cannot see it, but the URL is portingdb.xyz. It will redirect to Fedora porting db.xyz because in the future maybe some other distros will join us. And okay, go on. Sorry about that.
Yep. Anyway, the green bar is the packages that are actually ported at the moment. Yellow bar, or the things as you can see, it's 26 packages actually at the moment being ported in Python 3. Regarding the blue bar, there is some problem with the RPM. Upstream actually supports Python 3, but maybe the packager has not done a very good job on supporting or providing a Python 3 subpackage. So there are some issues with that. We always need more people or packagers to do this work as well. The other bar, the next bar, is the idle packages. Packages that are only in Python 2 at the moment, are not being worked on. So anyone can actually choose a package, pick it up, start working on it. The red bar, the most important one, is blocked packages. So some dependencies are actually not ported, so that means these packages cannot be also ported to Python 3. And the rest of it are packages that are not going to be ported to Python 3 because not going to be used or things like that.
We also have some groups of packages. So if you are interested in, I don't know, Fedora infrastructure or KDE spin, you can see it for the groups. Our main thing is Fedora Workstation, the Fedora desktop, the Fedora with GNOME. And since Fedora 23, which already has been released, Python 2 is not on the media, or it's not defaultly installed because all our tools there are running on Python 3. But you can still install Python 2 from the repos. We have only 1 minute, so I'm going to try faster. Those are packages being worked on, and if you scroll down, you can see bugs and everything, links about information, and you can also scroll down, and see all the packages that are that have problems, and then you can pick some package to work on. If you scroll a little bit back, up, you can see a manager-friendly graph on the right. We have 40% packages ported, but it's not a big number, but the packages are growing up, and the not ported packages are usually some crazy stuff like WAV extract, which extracts sounds from JPEG images, and nobody uses it. And we also have a dependency graph. Be fast, show the dependency graph before they clap. And you can see which packages depend on what ones, and they form clusters. Thank you.
Thank you, guys. I would like to ask Juraj to come and tell us a word about Pythons.
Hey there, I'm Juraj. I apologize because this is one and only talk, which is not about programming, but I know that the lightning talk can be about anything. I'm sorry. I hope I don't need 5 minutes. So this is about something else. Yesterday I came home from PyCon, and my son came to me, "Hi Dad, I have a homework, I have to set my first email address." So I turned on the laptop, and while we were setting up his first email address, he's 10, so maybe it's too late, I don't know. But he's really much into snakes and reptiles. And my wife asked him, "Hey Dominic, you told me once that some snakes, they do have legs." And he said, "Well, yeah, not actually. They have. It's just spurs. It's remnants of legs. So actually, they have like small legs." So my message is, Python itself is quite impressive animal and also language. And but there's more if you see under the surface, because in X-rays you see the legs, so dive into it. Thank you for coming, and thank you for all of you for supporting PyCon SK. Thank you.
Thank you very much. That was interesting. I would like to ask Adam and Jesús to say something about DTrace sprint.
So hi, I would like to tell something about the information about DTrace sprint. We are starting tomorrow at 10, and I would like to welcome people who would like help port the DTrace patch, what we actually need, people who are interested in the FreeBSD and macOS X, and can help port the Jesús patch to these platforms, and also people who know how to compile code on macOS X can join us, and it will help us as well. So thank you.
All right, thank you. That was quick. I would like to ask Veroš to tell us something about pretty test fixtures.
Is it visible from the end? Yes. So let's try to image that you are trying to write some tests for your precious model in Django. This is small model which is called person. It has name, phone, and job. And when you are writing some tests on it, let's see test. You have to test, you create person, and you should test that the person has some name. So, but where and when to get some sensible names. Unfortunately, Python comes with batteries included, and there is a library for that. So, the library is called faker. It's in module fake factory. So on the beginning, you will import faker, then you create fake factory. And you can ask your fake factory to generate fake data for you. For example, name. Great. It created name for me. When you ask another name, it will create another name. If you, for example, need some phone number, create it phone number. Another phone number. If you need some company name, company, another company. If you need job title, job title. If you need some bullshit, it's there too. So how you can connect your fake factory to your tests. There is some other library for that. It's called Mummy or Model Mummy. You will just create recipe. My mummy has a book of recipes, so you will create recipes too. So you will create a file named mummy recipes, and you will say, I have recipe for normal person, and it will be created like person. If you don't fill any data, any fields of the Django model, it will create totally random data, which is bad because you don't want to name your people. So it will be better to create people by this way. So the name will be created from a fake factory name, phone will be created from fake phone number, job will be created as a fake job. If you have some expensive expert, you will just say, I will take normal person and change this job to bullshit. No problem. And then I will try to import some. I created test application. I imported recipes. This P is a person. P name is there. It's still there because I haven't created another person. Well, 1 minute, great. People. When you need more than one person, for example, you need a group of programmers, you will say quantity is 3. Now I have 3 people with different names, I hope. 4 P in people. 3 random people. It looks much better when you are running Selenium tests. And finally, here is a way how to run it in just a normal test case. You will import your recipe, create person as a people, and then test the name is longer than 4 characters. And now I manage test. Runs. It's great. It's all.
Thank you very much. That was interesting talk. I would like to ask Petra to come and tell us something about Blinky's async adventure.
Okay, hello everybody. Maybe you've heard about this module in Python 3 that's called async.io. I still get some really smart people coming to me and saying I don't really get what it does. So maybe I can explain it in 5 minutes. And I will request the help of Blinky here. You can see Blinky. This is Blinky. Say hi to Blinky. Here's Blinky's source code. So it's pretty much a class that has a setFace method, which sets a given face, and you can print it. There's a printing function that that actually prints it, and you can run Blinky, and it sets some face, and then it waits a while, then it sets another face. And the problem is Blinky is sad because he doesn't have any friends. So let's give him some friends. This is the same code, except there's more Blinkies. And for creating more Blinkies, I use what a clueless programmer would do, and I used some threads for them. So there's a thread for every Blinky. There's a print function that just prints all the Blinkies with a space between them. And this is really good. It's not web scale. It's just eight or nine Blinkies. When I upgrade this little print Blinkies function to the enterprise ready print Blinkies 2.0, this one adds a little time sleep between printing each Blinky, and there's a problem. It doesn't print really well. Why is that? Because when I sleep, other threads come in and start printing the row of Blinkies again, and it completely ruins my display. If you work with threads, you will run into this problem quite often. You can solve it with locking, but in a complex program, it's hard to tell where the lock should go. You cannot solve it with things like greenlets, if you know G-event or things like that. This kind of stuff will still happen. And for that reason, Node.js got really popular for solving this problem, and they solved it in this way. So here I have two functions, close eyes and open eyes, and each one does whatever it's supposed to do, and then it adds a callback, and there's some event loop going, and each function runs and tells that the other function should run in some set time. And in Python we have async.io for that. You can use Twisted, which is probably nicer for it. In Node.js you have the JavaScript syntax, so you can put one function easily in the other one, which might work for simple cases, but in harder cases it's really complicated. The problem here is these two functions form a loop. It's really a trampoline recursion, but what we want to do is a loop. And that is a problem that async.io and the async await keywords in Python 3.5 set out to solve. So if I rewrite that to an async function, I have a loop. And here it says, sets face, and then it awaits from sleep. So this says, this thing can block, anything can happen here. Any side effects will, from other, like threads of execution, can happen here, but everything between the awaits will not get interrupted. So I can be sure that if I use an enterprise-ready setFace 2.0, which has some side effects, I can be sure that nothing will I don't know my time, that nothing will interrupt and nothing will get in my way. And if set phase needs to interrupt, it needs to change to an async function, and I will need to call it differently. And at that time, I need to rethink my logic and see again if that is okay with me. Right. So everything works. Thank you.
All right, thank you, Petra. So I guess we reached end of the day. I would like to thank you all for coming and creating this wonderful atmosphere on this conference. It was our pleasure to have you here, and I think this is it for the talks of the PyCon. We had Friday Slovak Day and today the English Day. Tomorrow we will have some workshops. You have been invited for some of them, so I hope you will show up and have a good time. For the rest of the workshops there would be some probably spontaneous workshops that maybe we could arrange, or we could do a Python clinic which would be like a more social event that we could try to talk to each other and maybe code something. Yeah, and that's it. At the end, I would like to thank the Mr. President of Slovak Republic, Andrej Kiska, to take patronage at this conference. I would like to also thank the sponsors for supporting it, so we were able to be here. Most of all, I would like to thank speakers for having a great talks and learn us a lot of new things. I would also like to thank you, the volunteers, who have been running around for 2 days and didn't stop and did a really, really great job. And I would also like to thank Faculty of Informatic and Informatic Technologies for letting us be here in this nice new auditorium. And yeah, that's it from me. If you thanks. All right, thank you guys. If you find something that you didn't like and you want us to improve, you can send email to feedback@pycon.sk, and we would like to learn even positive or negative feedback so we can be better next year. Thank you and see you tomorrow for those who will come.
Well, we only want this one, right?
You're funny. Has anybody asked anybody to take a picture?
Just ask them, right?
Yeah, no, you want to ask me, I think the name is Marion.
You're not that tall, Tom. Well, compared to you, I'm really tall.
Leave me alone.
Come on, Julie,
What?
do it. Julie. Oh yeah, I just.
It was on, Julie.
Oh, God, that goes.